Welcome back to Demystify Sci. I'm Anastasia.
I'm Shiloh.
And today we are talking consciousness. With us for this discussion, we have Christof Koch, a neuroscientist who is best known for integrated information theory, a theory that, as opposed to most other theories of consciousness, does not begin with the brain and then try to boot up consciousness from the biological goo that's inside of all of our heads. It starts with consciousness first and then tries to understand what are the structures that are necessary to actually be able to engage with this astounding phenomenon.
And what's really exciting about this particular interview that we're doing today is that Christof came to some rather recent realizations through experimentation with psychedelics that perhaps the simple physicalist models are incapable of addressing some aspects of experience which is accessible to us. And so that transformation is really at the heart of our discussion, because he's spent his entire career coming at this problem of consciousness with one modality, the traditional modality, and yet he has access to a new revelation about the nature of consciousness, which goes beyond even the human being or the sense of I, the sense of self, the sense of past, but persists in this really profound way. And so that transformation is what makes this a really unique conversation.
If you want to follow up on some of the ideas that we talk about, Christof has just released a book called Then I Am Myself the World, where he details all of the intricate moving pieces of integrated information theory. He tells the story of his mystical experience and all of the downstream implications that he has come to realize after that event. And so in the conversation, we don't actually do integrated information theory in the sense of, okay, tell us the postulates, tell us the axioms, because there's a ton of content that is already available, and if you're curious, you can go listen to Christof talk about it, you can go read his book, and what we really wanted to understand is more of the philosophy that drives him, more of the experiential knowledge that he has accumulated that has allowed him to formulate his ideas.
Remember, guys, this program is entirely listener-supported. We're working exclusively on a patron model, just like in the Renaissance, and so far it's working out. You'll see we have an enormous list of patrons for how small our podcast is, and that is everything to us. We take the time every week to meet with our patrons and hear what they're excited about, what they're not excited about, who we should be talking to next, and I would love to see you there, because it's such a heartwarming experience that we can avoid selling things and taking on sponsors and really just be funded by the people who care about these investigations as much as we do. So consider checking out patreon.com/demystifysci.
And if you are looking for some clothing, we are also selling t-shirts down below. If you don't have any cash to spare, that's totally fine. You can like, comment, subscribe. You can share the podcast with a friend. You can leave a rating on any of the podcast stores, or you can come to our Discord server where people hang out. We have a Facebook page and a Twitter account. So just connect with us, tell us what you think. You can suggest guests by emailing demystifysci@gmail.com. And we'd love to hear from you.
Tell your friends. That's the best thing. Otherwise, I think you guys are going to love this conversation, and we'll see you next time.
The scientific revolution starts now.
Demystify Sci podcast.
Let us see in the dark.
What have you been working on this morning? Institutional stuff.
Well, I'm trying. 2 years ago, I started a company to take all this knowledge that we have about consciousness. And, the mind-body problem can come across as very sort of abstract, very speculative. But imagine that coming from this interview, you have a bad car accident and you are traumatic brain injury and you're unresponsive, and you come into the clinic and they put you on ventilator support, but you don't respond. People ask, Shiloh, can you hear me? Can you move your eyes? Can you move your fingers? You don't. And if you stay in this state for 3 or 4 days, the doctors will initiate with your family a discussion. Is this what you would have wanted? And in 80%, 4 out of 5 of these patients they decide, no, this is not what they would have wanted, and ventilator support is pulled. Yet we now know, in fact, today there's going to be a paper published in New England Journal of Medicine, the highest impact medical journal, showing that up to 30% of these patients that are behavioral unresponsive are actually conscious. So in other words, that there is someone home, but either they can't hear you because the auditory cortex has been destroyed, or they can't respond because their motor structure or their language areas have been destroyed, or they don't have the cognitive capacity to respond to you. And so we, together with Tononi and Marcello Massimini, for the last 20 years, developed this device, which, have you heard of a technique called TMS, transcranial magnetic stimulation? So essentially, it sends a brief pulse into the brain. So it's like you hit the brain with a magnetic pulse, and you're listening to the echo on EG. And you can essentially compute the complexity of the brain response. And if you're conscious, like you and I right now, or you are in a dream, you're in a REM, in sleep, but in a REM state, or you are unresponsive because you're on a ketamine anesthesia, but you're actually conscious, but you're just dissociative, the brain complexity is high. But if you're a healthy volunteer but deeply asleep, the complexity is low. Or if you're a healthy volunteer in anesthesia, surgical level anesthesia, your brain complexity is low. And in most patients with vegetative state or coma, the brain complexity is also low. But we can also see in a subset, roughly 20% of these people that don't respond, they have high brain complexity, very similar to the brain complexity that you and I have.
And so the idea is to be able to identify whether or not there's actually reason to continue ventilation.
Yeah, well, first and foremost, is there someone at home? Because if you're conscious, even though you're sort of in this state, you're in a bad shape, of course, but you're much more likely to recover, to show functional recovery, a month later than if you're not conscious.
Mm-hmm.
But first and foremost is what you said. So people, when you get that phone call, there are three questions people ask. First and foremost, are they alive? Second, are they there? And then thirdly, yes, will they recover, or when will they recover? And so we can we can answer the second question, and if we can answer it positively, you're much more likely to be able to answer the third question in a positive way. And so, so it's a practical. But it has to be practical. It has to be, you want to be able to do this routinely in the clinic without requiring a team of 3 PhDs and a professor to come in and take 2 days. So, it's nice to have this research prototype, which is what we have now, but now we're actually trying to get it into clinical practice. And if you've ever been in ER, it's incredible dense. There are people running around, there are 20 beeping monitors. And so, you have to make it practical, quick, easy to use, without too much training, et cetera, et cetera. So that's what we're dealing with right now.
How far along are you?
Well,
yeah, let the man eat.
We have it now in a few clinics in MTA. So it's very early days. But we're working now with neuroscientists at Harvard and elsewhere to try to just get it established and collect data. That you have to do, of course, clinical trials, you have to get FDA approved, etc.
Yeah, I wonder if Neuralink will play into that in some sense, that people would be able to communicate even if they couldn't access their motor cortex or their speech centers. It's kind of interesting. I mean, it's quite a ways off, but for me, the few times that I've been in a state of unresponsiveness but still conscious, it's very terrifying that you can't actually, like, sometimes I think it's very common people have these dreams sometimes where they're trying to wake up but they can't, like
sleep paralysis.
Yeah, I've experienced that a few times, and a couple other things that border on that, and it's really one of the most anxious, awful feelings imaginable, and so I think finding a bridge for people would be a huge help, at least so they can say, like, I'm here.
One technique, it just doesn't work very reliable. You can get people to try to do imagine so-called motor imagery. So I can ask you, Shiloh, walk through your house. Imagine you walk through your house. You come into the front door, you go to the right to the kitchen, you go upstairs into the bedroom, you go to the bathroom, etc. This activates a particular part of your brain, the parahippocampal place area, that's involved in spatial navigation. And if you can do this reliable, then you can use that to communicate. Versus, for instance, trying to imagine playing something like, or imagine running, where you activate your large leg muscles. If you really try to imagine that, what happens, you activate your premotor structure, not your motor cortex, because you're obviously not running, but you can think about it. And again, you can use fMRI to pick that up. And so you can then try to communicate. You can ask yes, no question. If it's yes, think about going neural navigation. If it's no, think about playing soccer. It's very laborious, and even healthy volunteers have trouble doing this reliable because it really takes a lot of focus. And of course, these patients aren't really.
And it lights up on the EEG, or is this functional MRI?
It's primarily fMRI. They're trying to do it in EEG because that would be somewhat easier and somewhat more practical than putting a patient into this gigantic machine that you don't have in the ER, et cetera, et cetera. And if you can do that, that's a good indicator that you are conscious. But there are many people, even, as I said, healthy volunteers, only 80% of healthy volunteers can do this because it really demands your full attention. You need to remain focused on this task. And so many patients simply aren't able to do that.
That seems promising. I like that. Yeah, I recently, I was listening to a podcast with the first Neuralink patient, and it was really incredible. I mean, it's obviously not sustainable right now. The technology, like the brain shakes itself loose from the electrodes very quickly, it seems like, but the promise of being able to actually direct things with your mind despite your body being disconnected seems to be somewhat right around the corner, at least for patients.
It's been that way for the last 30. I mean, the first patients like that were done in the 90s. So far, typically, this was just a research prototype that required literally a team of 10 people. And you have this electrode protruding out of the brain. The promise with Neuralink, Elon Musk company, is that we can do this. Nothing is visible from the outside, right? It's a big deal because then you don't have infections, etc. As a conduit, you could do it on your iPhone. Can we do this in relatively faster pace? So over the last 20 years, there are 50 patients, 50. So it's a very small number. Neuralink wants to dramatically scale that up to almost make it like you go there in the morning and you get the thing implanted into your brain, and by the afternoon, you can leave the hospital. That could really have an impact because there are hundreds of thousands of patients, who lost due to stroke or car accident, they lost use of one hand. So right now it's in quadriplegic, right? The first two patients.
Yeah, one thing that was kind of sad was that the guy that I listened to, it had stopped working pretty quickly. And there was no clause in his patient contract that they ever restore it, essentially. And so he had this really profound experience where, his life had been restored to some extent. He could at least play video games and do things he loved, participate online, scroll through headlines, do that kind of thing. And he'd lost it. And so
but I thought they adjusted it. I heard in the meantime, because the brain, so you have these electrodes that sit inside the brain tissue, but the brain tissue, your brain moves, particularly, right?
Like a few millimeters, right?
Yeah, yes. And so the electrodes will move relative to the brain tissue. And so you might listen to a neuron, but then, it's like I shove a microphone into your face or move it away.
Yeah.
But I thought they'd fix that, no?
I mean, this could be a bit out of date. I think it was a few months ago, but they hadn't fixed it for him, and they didn't really have any plans to either. And so I thought that was a little sad. I don't know if maybe even a little predatory that they wouldn't take care of the guy for the remainder of his disability or his life. But I guess he still had the experience. He was grateful for it, but it seemed like there's an opportunity for this weird sort of existential depression to creep in for people who have that experience and then have it taken away again.
So even with this brain conscious meter, it's always fraught with ethical challenges. Turns out not everyone wants to know. We had
Yeah.
this case where a young woman fell backwards, badly fell down 2 sets of cement stairs, bashed her head
Oh,
in. Relatively young, so high potential for recovery. Family didn't want to know.
Oh,
And
wow.
partly what's hovering there in the background, are you willing, particularly if I can't tell you whether your loved one is going to be ever get better, right? Do you really want to know and then care for this person for 20 years, although they'll never be able to walk? I mean, it's a very tough decision. Yeah. So the other thing, for example, with electrodes, you can get tissue formation inside the brain. So you have electrodes in the brain, you can listen to them. But over a while, the immune system reacts and sends those microglia in and seals it off, because from the point of view of your immune system, it's a foreign body, right? And then over days or weeks, the electrodes, the signal becomes weaker and weaker.
How important are theories of consciousness in designing something like Neuralink? Is it purely experimental, or is there a theoretical basis behind it?
It's primarily based on 100 years of animal experimentation, right, in mice or in other animals, and in few patients. But like all of these techniques, they're first going to be tested in animals, mice and rats, pigs, non-human primates, and then in humans. The brain is by far the most complex piece of highly active matter in the known universe. And so technology is just one issue. Even if you have good technology like Elon Musk has, there's still thousands, tens of thousands of unknowns, like which neuron do you listen to? Even if you listen to every neuron, how accurate can you read out the information? Is this the right place to read it out? You maybe need to record from over here. What are the long-term consequences? How does the brain react to that?
But having a theory of what consciousness is helps with that, or do you feel like the...
Oh yeah, if we had a theory where people accept that we have a theory that can be tested, but all the theories we have, even the ones that I defend, IIT, are still, it's a thing in principle, but in practice, it's a little bit like physics in the 19th century, when you could predict the orbits of planets because they are isolated. Effectively, you can reduce them to a point on an elliptical orbit around another point, the sun, right? But you couldn't compute anything, practically speaking. That's only towards the end of the 19th century and then 20th century. This is where neuroscience is, or this is where theories is today. In principle, if we had a theory, we could sort of generically predict certain things. But then when you're faced with the enormous complexity of a brain that has 100 billion components, each of those components is connected to 50,000 to 100,000 other components. There's nothing like it in human experience. And so trying to predict that, if we can ever do it, I'm not sure we can ever do it, but it's far out in the future. So by and large, it's empirical.
Yeah, and even if you could do it, it seems like there would be a lot of diversity between individuals, right? I mean, what they've just recently mapped like a worm or something. I think maybe they've done something larger by now, but that was what, 300 neurons or something?
302 neurons, yeah. C. elegans.
Yeah.
But they've now done the fly, the Drosophila fruit fly, 80,000 neurons, yeah. And that's in one animal. That's in one
Right.
a couple of flies. And I use one of my first experiments was in flies. You send them down a tunnel and they come to a branch point. And 30% of the flies will go towards the left. You have a bright light there. Let's say you have a tunnel and one of them has a bright light, the other one is dark. 30% will go to the left, 40% will go to the right, 20% will stay put, and 10% will walk backwards. And, even a simple fly, because even a simple fly, 100,000 neurons is a tiny fraction of what we have. But that's already vastly more complex. Physics is really good when it deals with things like one photon or one, the magnetic moment of one electron or one star that is so far away from everything else, you can approximate it as a point, right? Or it's perfectly spherical. Biology, even a simple biological system has thousands of degrees of freedom. So,
well, with physics, it's interesting that you say that we have this correlation between physics and neuroscience, where you get to the point where you can have a mathematical way of looking at gravity and then you can understand orbits. But we're still at the point where we don't understand gravity well enough to be able to manipulate it. And presumably, if it's a causal structure inside of physics, if you understood it fully, you should be able to manipulate it.
if we had the power to do that, I think gravity we do understand. I mean, we don't have a quantum mechanical theory of gravity, although there are lots of candidates. But gravity is such a powerful force, bending space-time, that there's no simple way we can manipulate it except by having massive objects. So even understanding something doesn't necessarily mean we can manipulate it, right?
But maybe we could. But maybe if we had that unified theory of gravity, we would be able to disconnect atoms from one another or something. We could imagine whole new propulsion systems. I mean, this is fully sci-fi at this point, but I'm just saying that it seems like if that gap was closed, that there might be some potential there.
Yes, there could be, but but all I'm saying, there's a difference between epistemic knowledge, knowing something, and even knowing how it works in full and complete detail, and being able to do something about it, to have the causal powers to manipulate, either because the energies involved are so vast that we cannot concentrate them in such a small volume, or because in terms of the brain or molecular biology or the body, etc., because of vast complexity.
Well, with physics and causality, which I think causality plays a really important role in the way that you see consciousness.
Yes.
And so with causality and physics, if you have a completely physicalist view, you can perhaps envision a structure of some sort that could then be acted upon in order to cause change. Like space-time is inherently immaterial in some way. Like it
schematic.
It feels more like a mathematical structure than a physical one.
Like a wiring diagram.
That really depends on your metaphysics. True. Right. Yes, at one level, it's certainly a convenient mathematical fiction to describe things in space-time. It's very powerful. But some physicists reify it and think this is ultimately what truly exists. Yeah, it depends on your metaphysical position.
And so, what are the...
We gotta let the guy eat his breakfast.
Okay. I mean, it's fine. I'm almost done.
Yeah, let him eat. We can. This is your moment to share your own ideas.
No, that's true. That's true.
It's something. That's a topic that we play with a lot. Actually, our agent is selling our first book about this subject, which is the reification of ideas like space-time and so forth. And we have this hope that if we were able to recognize that they're reifications and start searching for material explanations for physical processes, not for conscious processes, right? We're not materialists or anything, but for physical processes, that we might be able to better understand how to, well, first of all, we would be able to better understand those processes. Students could engage with them more easily, and you would open up the landscape of possibilities for technological innovation as a result of it. So that's something we play with a lot. I mean, you can have a very, very accurate and highly predictive mathematical model. Like, one of the things we bring up this example all the time, which is genetics and heredity. People had a really decent architecture for how heredity unfolded, and they were able to do breeding programs and manipulate it long before they had any concept of the physical mediator of that process, which obviously turned out to be DNA, RNA, that whole physical world. And the thought experiment is, could we have developed our full panacea of modern medicine in the absence of a physical mediator for genetics?
Like if we had remained forever in the statistical paradigm of biology and inheritance and just said, it doesn't really matter what's happening inside the cell. Like imagine that we never had a microscope. Like you live in a universe where there's no such thing as a microscope. And so
in the center of the cell, there's genetic fields that control heredity. And they're perfectly predictive and mathematical, and you can wield them, and they're vector potentials for different inherited traits. Could that have been sufficient to produce CRISPR-Cas and gene manipulation and all of this?
That I doubt. Neuralink, yes.
Mm-hmm.
mRNA vaccines, I doubt it, because that really requires a mature, deep understanding of actually the molecule of mRNA and how to assemble it, how to make sure it doesn't trigger the immune system, how to generate the exact code, the sequence of nucleotides for an mRNA.
Yeah, I agree. And so I think that physical interpretations of quantum mechanics and so forth, and of the atom, and really considering the physical structure of the atom and how it does all of its magic, could also open up a whole slew of technological innovations that we can't even conceive of right now, in so much as we're comfortable with the reifications and the predictive power of those systems.
You know this book? I'm just reading this book called The Blind Spot, which is all about the. So it's written by two physicists and a philosopher, Evan Thompson. Wait, I have it next door.
we had the idea, huh?
What, you would have had it without me?
I did. I brought it too.
I could never even think about how it's without me.
So let's see. Adam Frank. Yeah.
Oh, we've had Adam on the show before.
What is the subtitle? It's why science cannot ignore human experience.
But it's much more general. So it's written by two physicists, and Evan Thompson is a Canadian philosopher of mine. But it goes into detailed history of classical physics. Then it has this goes into history of time, our notion of time, starting with it really starts with Aristotle. It's very nice historical. Then it goes into quantum mechanics, the various interpretation, relational quantum mechanics, Bayesian quantum mechanics, the various interpretation of quantum mechanics. Then it goes into cosmology, and then it goes into the mind sciences. I haven't gotten to that part yet. And it always asks about, in this, in the classical physicalist worldview, what are we missing? This bifurcation of nature that talks a lot about Alfred North Whitehead, this bifurcation of nature, right? Where we say, well, nature, we leave out all the secondary qualities, right? We don't talk about color and pain and all of that. We only study particles, as it did in the 17th, 18th century. What are we leaving out? And then we're trying to solve the hard problem, because now we sort of have to put back into things that we took out in the first place. Quite good. Anyhow, so I'm done.
All right.
Excellent. Well, so with to kind of wrap the thread of physics and the ability to create some kind of technological intervention, I have a feeling that there was some kind of philosophical break where we got to something that was so difficult to conceive of, and we had sufficiently little data that we accepted that it was enough to simply map the forces and to come up with the mathematical frameworks for dealing with the forces. And that's kind of what has led us to the place where we are right now, where the mathematics is good and sufficient for predictive ability. And now when we go back and we're like, okay, well, how do we integrate this entire picture? We're left with kind of a paucity of imagination. And instead we rely on very spooky and weird interpretations of the results of the data. Like, have you heard of the transactional interpretation of quantum mechanics?
Transactional, not under that name, no.
Well, so John Kramer and Carver Mead. Carver Mead was at Caltech. John Kramer.
Oh yeah, I know him very well. I worked with them. I published with them.
Okay, well, so they have a theory. They have an interpretation of quantum mechanics which deals with the strangeness of quantum phenomena being a result of communication between atoms, as opposed to something that is inexplicable and purely non-local. Where, for example, if you take an atom and that emits a photon, if you have a one-atom universe, is it still possible to emit a photon?
The transactional would say no, I suppose.
The transactional basically says that the photon is a resonant exchange between two atoms. And so there is this phase relationship between the atoms which allows them to exchange information in the form of a photon.
So it sounds a little bit like relational. So there's Carlo Rovelli, right? He proposed this relational quantum mechanics. It seems somewhat similar, but I don't know enough about these various interpretations.
I haven't looked into Ravelli yet.
Where were you going with it, though?
I was just going to the idea that we have an immense amount of data, and that data is now at the point where it requires a functional interpretation. And it seems like the study of consciousness and the study of the brain is in the same place, where we have, like you said, centuries or a century of data about the structures of the brain, about the way that the brain responds. We have these advanced tools for being able to look into it and to see how it will react to various perturbations. And now the challenge is to be able to come up with some kind of interpretation of that data that allows you to actually have a holistic, functional picture of what is happening. Do you think that that's a fair way of seeing it?
That's one way of viewing it. But, so I was early on today, I was attending adversarial collaboration that I helped initiate in the field of consciousness. And they're now releasing all the data from 250 patients in 250 subjects, mainly healthy volunteers, fMRI, EEG, MEG, eye movements, and behavior. So it's 38 terabytes of data. Okay, it's just realms and realms and realms and realms of data. So when I think about that, what you just mentioned, I think about that, somehow we have to pull out of that some sort of understanding. And every one of these instruments, MEG, EEG, fMRI, has various spatial temporal filters, right, and only sees certain things and trying to infer what's going on. It's just an immensely complicated problem of the sort that humanity really hasn't faced. And is human ingenuity up to it? That remains to be seen.
I think maybe a really general question to start with would be something like, why should we study consciousness? Why are these theories important in the long run?
Well, I mean, that's easy to understand because we define ourselves through consciousness. So the only way we know we exist is through consciousness. Even if I want to do science, the way I do science, the way I look at gauges on trace on an oscilloscope, or I look at pictures of particles decaying in a bubble in a cloud chamber. It's always through seeing or hearing or touching, right? So the only way I know of me that I exist, this is shades of René Descartes or others or anything, is by consciousness. And it's a puzzle how consciousness, how that fits into our scientific worldview that has been so good at explaining so many things and it has led to so many technological advances, right? We're talking about mRNA vaccines and quantum computers and fertilizers and whatnot, right? So I think it's a natural question to ask, how does consciousness come about and who else has it? Who's conscious? Is the universe conscious? What would that mean? Are computer conscious? What would that mean? So I think it's one of the most obvious questions to ask as a curious person.
Why do you think that it's crept into the hard sciences? I feel like 50 years ago, this would have been relegated to a few philosophers, theory of mind people. but it seems like it's moving squarely into the hard academic sciences as a legitimate topic of investigation.
Yeah, it has moved into that. Well, partly because of work like pioneers like Francis Crick, or the work I did with him and others, pointing out, hey, how can you have it? So when I started some textbooks of neuroscience, when you looked into the index, there were no entry under consciousness. So if you think about it, we're studying this thing, the brain. We know how it feels because that's consciousness, but that wasn't mentioned until recently. I mean, that's shocking. You just leave out the major aspects. We don't have to ask that for the kidney. The kidney doesn't feel, right? The heart, doesn't feel. It's, you can have sensors, of course, on the heart that signal in the brain, but the brain has these feelings, these conscious experiences. So leaving that out is, so people have realized we can't do that. Our techniques are getting much better now. We're talking about Neuralink, so that's getting much closer to reading out conscious. What is the person experiencing, or maybe translating their experiences into actions. And even physics now talks about it because they have all these interpretational problems that we are just talking about, right? What do we do with these non-local, spooky, non-local interactions of entangled Bell's pair, right? How does that work? Well, maybe, like Roger Penrose surmised, maybe consciousness is involved in there. Yeah, so many sciences sort of have rediscovered what we took out over the last 2,000 years, where we went from the concrete, my experience of hot and cold, to something much more abstract. Temperature is average molecular motion, thermodynamic. So we had all this abstraction that led to these powerful mathematical theories formulated in a mathematical way, but we tend to now reify that. We say, well, that's what nature is, our abstract models, right? Where we mistake the map for the thing that we're trying to describe. And lo and behold, we leave out consciousness. And so now we have to put it back in. So now we have the map and we ask, well, how can I put consciousness back into the map? That is a hard problem. That's an explanatory gap. I'll never be able to answer that. Well, maybe we shouldn't. Maybe we should go back to square one and put consciousness in the beginning, because the only way I know about the map or about the world is through consciousness.
I mean, you seem to have changed your tune on this from what I can gather. I obviously have never met you before this, but I think I've read that you had a bet with someone over this idea that we would have figured it out by now.
Yeah, so I had a bet with Dave Chalmers. So Dave Chalmers is a very well-known, probably one of the best known modern philosophers, an Australian-American philosopher. Is at NYU. And he's the one that popularized the notion of the hard problem of consciousness. And the bet I had, it wasn't about the hard problem. It was when I was, we were both attending a conference on consciousness in Germany in 1998. And, you go out to a conference dinner, and then after you do a pub crawl. And then I was very young and brash and just started my lab and I said, hell, in 25 years, we'll understand this problem. We'll find the neural correlates of consciousness. And he said, no way. No, you won't. I said, yes, we will. And then we bet a case of good wine on it. And then last year I had to concede that I'd lost that bet. What does it mean? So the neural correlates of consciousness, the footprints of consciousness in the brain, sort of what are the mechanisms that are jointly sufficient, let's say in your brain or in my brain, for you to hear my voice, or to dream of my voice, or to imagine, hallucinate my voice under psychedelics or whatever, right? Is it a particular type of neuron located in a particular region of the brain? Does it buzz at a particular frequency? Does it express particular genes? Those sorts of questions. There's no doubt, and Dave Chalmers agrees with me, that in the fullness of time, we will be able to answer this question. This is an operational question. As long as you believe there is something to explain. If you're Dan Dennett, you think, well, all of this is deluded because consciousness doesn't really exist. But if you think consciousness is something real, then there will be some footprints of consciousness in the brain, and sooner or later we'll be able to identify it, study it, manipulate it, see what goes wrong when you have, let's say, schizophrenia and you're hearing voices. detect it when it's not there, let's say because you're a behavioral unresponsive patient in a coma, discover when these footprints first appear. Are they present in a second-term fetus? Do they only start appearing in a, once when a newborn cries out and has exited her mother's womb? What happens in Alzheimer, in late-stage Alzheimer? Which animals have these neural correlates? How do they change between, let's say, us and a monkey and a dog, etc.? So all those questions will have answers. But what is not so obvious, whether we'll ever understand, and this is Chalmers' point, so he says, okay, finally there will be correlates. I grant you that. And here is so let's say there's correlates if you are in love. Okay, you have this feeling of being in love, right? This ecstatic feeling, you can sleep at night, you constantly think about the person you're in love with, on all of that. And over here you have some neural mechanisms that support that. Okay, but why should these mechanisms support this? Why should any feeling, why should any mechanism, any vibration, molecular vibration, collapse of the wave function, electrical activity, 40 hertz, you name it, why should any of that go hand in hand with any feeling? It's just, there seems this gap, right?
To some degree, but it also seems plausible that if it is, let's say, a vibration, if it is some kind of resonance, that resonance has associated with it an embodied sensation. Because things are felt in the body as much as they're experienced in the brain.
Yeah, but but the challenge so here I'm channeling Dave Chalmers now, right? He would say, well, why 40 hertz? So one of the first theories that Francis Crick, when we published on this back in 1990, advanced, gave a lot of excitement, was that 40. So when you go inside the brain, sometimes you can see neurons fire. Let's say every 20 to 25 milliseconds, they have these action potentials. And that's roughly at 40 hertz. Or in the EEG, you can see sort of these oscillations that occur with a periodicity of 20 to 25 milliseconds. Okay. So we hypothesize, well, 40 hertz is one of the footprints of consciousness. Okay. Well, let's just assume for the sake of it, it's true. Well, why 40? Why not 30? Why not 50? Well, what is it about 40 hertz oscillation that they give rise to feelings, but 30 hertz don't? But again, how does any mechanism, no matter how construed, give rise to this ephemeral stuff? There seems to be a fundamental gap between the two. The one is about, third-person properties. There is electric charge, that moves inside, outside, and had, because of its causal powers to influence other charges. It can move things and can generate things like electrical activity and action potential. That's all perfectly fine. But then, how do you go from there to feelings of pain, or pleasure, of good or bad, or seeing or not seeing?
It's kind of like looking at for me, it's like looking at a really nice stereo system, and it's understandable how it can produce sound waves and so forth, but then the experience that you have of listening to music through it is so far removed from the hardware of the actual machine itself that studying the machine would never get you to the bottom of how I'm having this beautiful experience of this symphony.
Well, which is why I feel like a lot of the times when we talk about consciousness, we talk about human consciousness, and we talk about the human experience of listening to music and to the human experience of love or chocolate or red or whatever. And I'm like, okay, well, that didn't just appear for the first time in humans. Like, those experiences predate.
Yeah, the same. You mean evolutionary? Yeah, sure. Other animals. I mean, somewhere here's my Bernese mountain dog. Of course, my Bernese mountain dog is conscious. No question about it.
Well, not only that, but I'm like, okay, so if evolution is a manifestation of will, you have an organism, and it has a set of desires, and that set of desires drives it towards the fly, walking towards the light, staying put, or going towards the darkness, or turning away. There's this set of options that the fly can take. That population of actions is a result of some innate desire of the fly. And if you kept them in that kind of a system where you put them into the tunnel, they separate out, and then you take the flies that go towards the light and you watch them for 1,000,000 years, they might turn into a different creature than the ones that go towards the darkness. And so the like proto-emotionality is the necessity for evolution, because without experience, without...
No, you can. No evolutionary biologist would say evolution has a will.
I know, but I think that they might not be right about that.
I agree. So Schopenhauer, of course, would also disagree. However, you don't need feelings in order to get behavior, right? And this is the point when people talk about AI. AI isn't a threat because it might be conscious. AI could be a threat because it has certain maxims that it wants to carry out. Let's say it wants to make paper clips, right? And it just acts to optimize the number of paper clips, and it looks around at everything just with the point of view: is this material for paperclip? It doesn't need feeling. The fly, again, to walk down a tunnel, to walk down the bright side or the dark side, it doesn't need feeling. It just needs a mechanism that says, okay, here it's dark, here it's night, so you can just count photons. All right. And then you go to the place where it's darkest because you can hide better. You don't need any feelings for that. All you need is mechanisms.
But if all that you need is mechanism, and you have a population of flies that are genetically identical, then you would expect that the feeling would be the same across all.
No, because all the mechanisms are slightly different, right? That's why, I mean, this is the raw material of evolution, right? Because everyone, even in iso-identical fly population or mouse population, there's enough variability that the genes aren't exactly the same. We see it in twins, right? When people say, well, identical twins have the exact genome. No, it's not true. On average, they look very similar, but they're not the same. They're birth effects, they're birth order effects. And then, of course, as you experience, individuals will have different, even flies can have slightly different experiences, which manifest themselves in slightly different things like different synaptic weights.
But I'm like, okay, so evolutionary biologists refuse to talk about will as a measure of biology. And then we have this hard problem of where does the feeling of love emerge from? And I'm like, doesn't it simplify the problem if we start to consider will as being a vital ingredient? So my background is in microbiology. I studied bacteria. And specifically, I studied the redox systems in bacteria. And so...
Electrical communication,
and so there's this complex network of variably oxidized or reduced molecules inside of the bacteria. And what we found is that they respond to this redox stress by changing their genetic programs. They will behave differently inside of a biofilm. And obviously there's a very physicalist, materialist way of looking at this, which is nothing to do with desire or will or anything else. But in some primordial sense, the discomfort of an altered redox state is what generates the change. And if that is the most simplest form of will, of like, I will minimize discomfort by changing my genetic program, then doesn't it just lead to the idea that as you become more and more complex, your the perceptual conscious shell also becomes more complex over time? And so it's not something that just emerges in one place. It's this thing that across the evolutionary landscape becomes progressively more and more intricate.
Yes, I agree with you. I've done these simulations of simple. So when I was at Caltech, I had student and postdoc doing evolution by natural selection. So we had these simple creatures that had a genome that generated a simple brain. They were simple vehicles. So they had like two sensors. They could move forwards or backwards and turn left and right. And they had a very simple photoreceptor, and then they had some wiring. And they had to go through a maze to get food. And we started off with thousands of them, and they each had random initial conditions, and then most just stood stationary, and then some moved a little bit. And we took the ones that moved a little bit, the top 10% performers, took their genomes, perturbed it a little bit, put them back in, and did this 100,000 times, right? And so after a while, you get creatures that totally so you have this huge high dimensional space, right? That's the genome space. And you select always the ones that perform best using some metric. In this case, the metric I chose, how far did they get into the maze? And after a while, if you do this long enough, you get some creatures that really know they are adapted to the environment. They can go down this maze and get the food. And they go down there very, very quickly. And that's all mechanisms, right? Now, according to IIT, if you believe in IIT being a proper theory of consciousness, then as they get more complex, you can compute their intrinsic complexity. The integrated information goes up, and it's easy to understand why. Because the good performing organisms, they really need to integrate the different sources of information they have accessible to, i.e., their door on the left is a door on the right, and their eyes, their simple eyes, they need to integrate all that information in order to come to a decision. So it's relatively easy to explain why they become more complex, and why consciousness would also increase. However, we have to remember that evolution doesn't select for consciousness, it selects for behavior, right?
How can you tease those apart? I guess is the
because
question.
the only thing that evolution cares about, will you leave a descendant, right? Right. If you leave descendant, you're successful. If you don't leave descendant, you're not successful. That's what gets selected, right? So whether it's your microorganism, or in my case, these simple vehicles, simulated vehicles, what gets selected is the clade that survives in a particular environment. It doesn't care about whether these things see or feel or have pain or pleasure, right? It couldn't care less. All it cares is about behavior. Now, if you have a theory, however, that says as the brain becomes more complex, you have more wires crisscrossing, you have information from the front that goes to the back, because remember, this is random search. No one builds these machines in a particular elegant way. You have these very high dimensional spaces, and using your random selected genome, you meander through this search space. So yes, these creatures will become more complex. Yes, their consciousness will become bigger, but it's an indirect effect. And you can show this very nicely. And I would say on any theory, evolution doesn't select for conscious creatures directly. Same thing, we were not selected for our ability to write novels or to do mathematics, right? Now, we live in a civilization that's managed to produce things like War and Peace and the Lord of the Rings, but evolution obviously didn't select us for being able to write novels, right? It's a spangle. It's an evolutionary spangle, right? It's a side effect. It's not selected in the direct sense for that.
I mean,
if you're a blockbuster novelist, you probably get to reproduce.
Yeah, I mean, right? Because humans are storytelling creatures. We might be. I think it's probably reasonable to say that we're the only creatures that tell stories.
Yeah, that's true. But I simply don't think over the times that humanity evolved, particularly from the last 5 million years, that this was on average, that we are selected for doing things like math or writing novels.
And yet, our technology and our technological ability is probably what has made us human. And
yes, and has made us the most powerful species of the planet, so powerful that we're destroying our own house here. Yes, all of that is true.
And so it's hard for me to disentangle those things, because it seems like this comes back to what we were saying earlier, is that we have this materialistic lens of looking at science, and we've taken consciousness out of it. And so if we look at okay, so you go back before humans were around, and there's just this sea of primates. And you can say that the reason that humans evolved is because of their interaction with their ecological niche. But it seems fully plausible to be able to say that humans evolved because of all of these desires that they have, the desire to tell the story, the desire to make the tool, the desire to change the environment around
Where the
them in a very
monkeys don't have
specific way.
desires? Wolves don't have desires?
They do, and but they have the desire to be the wolf. They have the desire to be the monkey.
Yeah, and we have a desire to be human. How does that explain the rise of humanity? I don't understand. All animals have desires, including us. We were obviously more successful. I mean, given the number 8 billion people and the number of wolves and non-human primates around, we're obviously the most successful ones. Was that by design, or is it just a random, again, we're wandering through. I'm not sure there's an arrow here, right? Because what this will question implies that there's an arrow and that we have this ever increasing complexity that would naturally drive on any planet in any environment towards evolution of highly conscious creatures. Maybe that's true.
Yeah, it'll be so interesting to see. I don't know if we'll live to see it, but if we find other planets with life on them, if they're also tending towards something like a human being, that will be really, really fascinating.
I look forward to the octopus planet.
Yeah, I don't know what you mean by human being. Yeah, what about an octopus, or what about something that we can't really imagine? I mean,
either way would be really exciting and interesting. Maybe it turns out that this kind of planet is the only kind of planet that can support life, and then it turns out that the best, most successful organism turns out to be quite, a biped hominid that has,
I find it very
digitary.
difficult to believe. Plus, we in the next 100 years, either we blow ourselves to smithereens in a nuclear hellfire, or AI takes over and wipes us out, or global, environmental meltdown. So whether we are really that successful remains to be seen.
This is true.
Well, we're trying to get off the planet, right? There is there's
I know
something.
I'm all for it, but still.
It tastes teleological in some sense, that we're trying to get, like, that the Earth in some sense made humans, if you can say that, and the humans are trying to spread the Earth elsewhere. There's something there.
Yeah, Earthseed. I mean, you can read Ursula Le Guin, right? She talks about Earthseed. Hi, this is my conscious creature here, Bernie's mountain dog. Now, of course, you can take a very different philosophical view, so-called idealism, right, of particular of Arthur Schopenhauer, right, who's, I think, the most prominent exponent of this particular type of idealism, where he felt that ultimately everything is a manifestation of the will. Now, he wrote the first edition of his book when he was 26, which was before Charles Darwin, Theory of Evolution appeared. But of course, the theory of evolution would be fully compatible with that. Have you ever invited, so there's a modern computer scientist and philosopher, Bernardo Kastrup?
Mm-hmm.
Yeah, we've had him on the show.
Okay.
More than once, is that true?
Twice, yeah.
Yeah, we've had him on twice.
Oh, see, yeah, because he advocates, and I find much there to like. I mean, it's a little bit radical, throwing out all of the physical substrate being just a manifestation of the mental. But it has some very appealing elements.
It's pretty defensible, but at the same time, we have this shared reality, right? We have these shared experiences that we can depend upon. Like, I know if I walk out in front of a bus that it's going to end for me. I'm pretty certain of that.
Well, which he doesn't doubt, right? Right. He's a realist in the sense, yeah, he says there's clearly an observable outside there, like that bus that's coming down at you and you better jump out of its way. But he says that bus ultimately is a manifestation of something that ultimately is mental. I mean, it's a metaphysical thing.
Yeah.
So metaphysics, by its very name, meta meaning really before, right? So it comes, or it's underneath physics. And you can be a physicalist or an idealist or dualist or somewhere in between, while still being a regular scientist and do all the things that scientists do, right?
Yeah, you still got to brush your teeth at the end of the day and, eat food and everything else.
Well, not only that, you can still do microbiology or neuroscience, right? And you can still study all of that or do astrophysics while believing that ultimately everything is mental. But for now, I'm studying these physical manifestations because they're clearly lawful, right? They unfold according to some natural laws, right? He's a naturalist also. He's not a supernaturalist, right? He doesn't say this is God, but it's nature. So it's very Spinoza, right? Deus sive natura. I mean, nature or God. You can think of him God of nature, nature of God. It's the same. There's these inherent laws, dynamic laws, they unfold. And as a physicalist, we would say, well, they only unfold in the physical, or however we define the physical, which is, of course, challenging. Or you can say, no, ultimately, what's really there is the mental, the phenomenal consciousness, and it manifests itself in these ways that appear to be physical. And I find it more attractive now, given the challenges. I mean, I find it attractive for three reasons. One, physicalism has been unable to deal with consciousness. We talked about it, the hard problem, and all of that, right? It doesn't mean it may, in the fullness of time, explain it, but so far it's utterly failed. And telling me that I'm essentially trying to gaslight me into believing that my feelings of love or pain or pleasure is just an illusion or delusion. Illusion is what Dan Dennett uses. I think it hasn't worked out. Consciousness has refused to be canceled, number one. Number two, at the bottom of, we don't know what the physical is, right? The physical, what? I take two particles, they're entangled, entangled. I put them at the opposite end of the universe. They're in this ghostly superposition where, they could be like this or like this, but they're in a superposition of both. And when I observe one, then instantaneously, even though the other one is light years away, that determines the other one. Well, for sure, that's not my grandfather's notion of material or physical, right? So it's really getting spooky. We're talking about relational or transactional quantum mechanics. It's really getting spooky down there, where it's supposed to be the best model we have of reality. Well, we can compute, but we don't really know what it means. And then I had my own experience of mind at large, and having encountered that, I feel much more sympathetic now towards these ideas of idealism.
Yeah, I wanted to talk to you about your experience, and is it all right if we reference the book that is coming out here, or we won't quote it or anything? But you sent us a preprint.
It's out. I mean, what?
Oh, it's out.
This book?
Cool. Yeah.
Yeah, it is.
Then I Am Myself the World.
Okay.
Then I Am Myself the World. Yeah.
Very good. All right. Well, everybody should check it out. It's very beautifully written, and it seems to tell a tale of a transformation that you experienced. And I'm curious. I mean, this is kind of why I brought up the bet,
Chalmers.
The Chalmers bet, because it seems like you have undergone some transformation that has reoriented you to this problem.
Well, so as a disclosure, two things. I went to a French high school in Morocco for 3 years. I have a French baccalaureate. The high school is called René Descartes. It's named after Descartes. So, furthermore, I grew up in a devout Roman Catholic church. So it came very natural to me, when I came of age and, as an undergrad to start think about it. I got this undergrad degree in physics and minor in philosophy to think about sort of dualism. Was very natural for me. Right, there is the physical stuff that physics described, and then there is consciousness. And it's always been obvious to me. My consciousness, my feeling of pain and pleasure is obviously different from the stuff inside my brain. In fact, there's no, I see you. This is this light-filled scene. There are these beautiful trees outside there on my island, but inside my brain, it's dark. Right, it's just filled with squishy, gooey, white, red stuff, right? So that was always obvious to me. Now, as I grew up and became older, I rejected Catholicism because its assumptions are just too, incompatible with what I know about the world. But I always had this strong belief. And when I worked for 14 years with Francis Crick, we try to explain how consciousness comes about in entire natural ways without invoking this thinking stuff, as René Descartes calls it, right? Res cogitans. But then it keeps on coming back. I mean, this is the hard problem. How do feelings come about? And so then I helped develop this theory of consciousness, integrated information theory, that puts consciousness first, right? So unlike almost all other theories of consciousness that take the brain and try to squeeze it in appropriate ways, let's say functional, what's the function of the brain? Let's squeeze out the function, or it's broadcast. So that's a function of consciousness. And so now I'm looking for a mechanism to broadcast. Or I'm looking for something like 40 hertz oscillations or quantum mechanics, collapse of the wave function. But you start with the physics or the psychology, how this brain behaves. IIT is different. IIT starts with consciousness and says fundamentally what exists is consciousness, and then it looks for what is the property of every conscious experience, and then it looks for a physical substrate that can instantiate that. But then in my further evolution, I had this one extraordinary mystical experience, I guess one could call it. I had a number of them I talk about in my book, but the title of my book is taken from the second act of Richard Wagner opera Tristan and Isolde. Where the two eponymous lovers, Tristan and Isolde, they merge, and they have this. They say then I myself the world. They become one, and they become identical with the world, which is sort of the beating heart of a mystical experience. When you lose yourself, but it's not only self-dissolution. I mean, you can dissolve yourself. The ego can dissolve in a variety of conditions, but then also you have this feeling of transcendence, of having peeked behind the curtain, of knowing what the universe truly is. And this was my experience, that it's what Aldous Huxley in his book, The Doors of Perception, called mind at large, where I felt whatever remained of me became identical to this mind at large that underlies everything. It's very difficult to express in language because obviously our language doesn't have the words for that. So it's, in this sense, it is ineffable. And you bring back this feeling that William James, the father of American psychology, he wrote this wonderful book. It's a classic, worth a read, written in 1902, The Varieties of Religious Experiences, where he essentially defines mystical experiences, not just religious experiences today, but near-death experiences, psychedelic-induced experiences, aesthetic experiences that people have had throughout the ages, throughout the cultures. Whether you're religious or not, you can have these experiences. And one of the key properties that he describes is what he calls noetic. You bring back some knowledge, nous, Greek knowledge, some noetic quality from your experience that others don't have to take at face value, but the experiencer knows. They have seen it, and they know this is what they bring back. This is just the way. I don't have to argue about it. I don't have to be convinced anymore. I now have had direct experiences. And that's what I bring back from my experience, this sort of feeling of having this unity with this cosmic mind, or becoming identical to this cosmic mind in some way, shape, or form that I don't really understand.
I mean, if there was a cosmic mind, it would make sense that it wouldn't be evolutionarily advantageous to be in direct contact with it at all times. Like, it would make sense that we would be cut off from it to some extent.
Correct. Yeah, this is what Bernardo argues. Otherwise, it wouldn't have evolved, right? Because what's the point of evolving these tiny creatures if I can know everything all the time? So evolution works on individual organisms, yes, and so there's this challenge to explain, if there is a cosmic mind, why don't I access your mind? If we're all part of the same mind, right? You guys don't access my mind. You don't even access each other's minds, right? you can infer what you're thinking because you live together and so you know each other extremely well, but ultimately it's always an inference. You don't directly know. So why is that? Well, so we have to have mechanisms in the brain. Huxley calls this the reducing valve theory, right? We have to have mechanisms in the brain that prevent us from accessing this universal mind, which would make sense to prevent this for evolutionary, because I need to maximize my gain and my genetic lineage, right? Not your genetic lineage. So it would make sense. And then somehow during a mystical experience, somehow that reducing valve has to be eliminated and or opened up such that now so typically this always happens when people talk about it, their own identity ceases to exist, right? Their own self, their memory, their particular drive, their particular ego, right? All of that is gone. That's typically what's always described in a mystical experience. Your ego, including your body, your memory, what makes you distinct, all of that goes away in this merging with the absolute somehow. This is also what may happen to all of us at the end of our life, that we lose our identity, so we die. So the Christof will cease to exist, so most likely. So it's very different from Christian eschatology, you know, where me and my memories and you know my memory of my dog, etc., persist in paradise. Under this view, none of that would exist, and you would cease to exist, and you would return to where you were before you were born, to this cosmic entity.
I hope that's true. That's beautiful. Is there some has anybody looked at the overlap between these mystical experiences and, say, near-death experiences where people approach that moment and come back?
Yeah, so there are studies where people have done that. Well, what they've done, they've studied under psilocybin and compared. So there are these questionnaires you can take, you can give to people called MEQ, Mystical Experience Questionnaire, and the various versions of them, and where you can show that people who have near-death experience turns out not to be that uncommon. So up to 10% of, for example, cardiac arrest survivors in hospital, where you're more likely to survive a cardiac arrest than outside, will report NDEs, near-death experiences. Typically, they're positive, although not always, which is a surprise, because, you know, when your heart stops, it's extremely painful. You know, it's extremely anxiety provoking, to say the least. You know, many people die, most people die, of course. You have all these people rushing at you and trying to save you and all of that. It's really a miracle that people report these very positive experiences, right? Of losing pain, of floating, of losing their identity. And typically this goes hand in hand with the loss of fear of death. Quite remarkable. I had one near-death experience at the onset of the pandemic, and I can ascertain that I lost my fear of death since then. I discovered that a few weeks after my NDE, it left me. This fear of death has simply left me. So people have done psychological comparison, near-death experiences and psychedelic-induced experiences of the mystical type. In other words, where people report oceanic boundlessness and ego dissolution. And they do seem to be very similar. We don't know the brain mechanisms yet of either. Near-death experience, of course, is difficult to study. Psychedelic-induced mystical experiences somewhat easier to study, but people haven't so far done it at the moment of the mystical experience, because it's not quite clear how you would actually go about doing that.
What do you wonder where that loss of fear of death comes from? If it's just knowing the unknown, if it's actually a fear of the unknown, and since you touch on it and it turns out to not be this scary situation, perhaps it's not something to be feared anymore. I think we all have a natural, healthy fear of the unknown because, well, anything could happen.
Yesterday I was reading this, there's this book here, Philosophy and Psychedelics. There's one essay here on someone who's a Spinoza fan, And he compares the whiteout. So there's, you know, this drug called the toad, the medicine called the toad.
Mm-mm.
I've heard of people licking toads before.
Yeah, you wouldn't want to lick it. Some of them they're very toxic, but you can from the gland, or you can now synthesize it. There's a substance, 5-methoxydimethyltryptamine, 5-MeO-DMT. It's also known as a toad. And you inhale it typically, and then people report these whiteouts where they see a bright light and then nothing else, and ego dissolution, and then they have these. Here, a person describes it. It's like a supernova suddenly exploding silently in the center of your head, like looking at the center of the sun at midday. You're a drip in the ocean, that suddenly becomes the entire ocean, and then you are in the entire ocean in a drop. It's short lasting, 10 minutes, but you also lose the sense of the time. So it's a sense eternal, and eternal not of being endless time, but no duration. You lose. So one thing you experience if you have one of these, that the perception of passage of time, duration, right, itself is a construct of the mind that under extreme cases, like when you take 5-MeO-DMT, can disappear. And in this chapter, this author, which obviously has experience with 5-MeO-DMT, compares it to Spinoza's intuition of encountering sort of the Godhead, what he calls Deus, the intellectual love of God. He thinks that's the moment, that's what happens when you, under this extreme form of of psychedelic-induced experiences, Deus intellect, what did he call it? The intellectual experience of God, who is identical to nature, according to Spinoza. Spinoza was he was the one who said that nature and God is identical.
Hmm.
So how does this change your approach to science after you have this experience, or your approach to studying consciousness? Does it change it, or were you already leaning towards the ideas that you stand with today?
Already leaning towards the idea. So it's a good question. That can you be a legitimate card-carrying scientist, whether it's neuroscientist, in my case, or physicist, while still being an idealist? And in principle, the answer is yes, because I'm not denying that these things exist. I mean, as you mentioned, that that the bus out there can kill me. Right? It's not a figment of my. I'm not claiming. I'm imagining all of this thing. What idealism is claiming, that all of those, including my own brain and my own mind, are ultimately manifestation of a single, undifferentiated, maybe even quite primitive mental entity, mental thing is. But I can then still study, using science, using the laws that are apparent in this the only reality that's accessible to me, which it certainly includes chairs and tables and brains and electrodes and magnetic scanners.
Is this a field theory of consciousness then?
Nice.
No, because the field will still be something physical as construed in a standard physicalism. Now, as we just talked, it's really difficult to nail down right now what physicalism is. So on the one hand, we have theories, empirical theories, like, for example, Maxwell's theory, right, of electromagnetic fields, where we can talk about fields, or we can talk about quantum fields and quantum mechanics, right? On the other hand, we have philosophies like idealism that are not precise scientific theories, right? So how is this? You ask a good question. How does this universal mind manifest itself?
Well,
does it manifest itself in a field? Then I should be able to access that field. Is it like radio waves? And my brain, accesses only a tiny fraction of the radio waves, and somehow when in these mystical experiences, suddenly I can capture all of it.
It kind of sounds like that. I mean, it sounds like a rediscovery of God in a way. I mean, I know it's a dirty word in science, but It's interesting to me that we tried very hard since the Enlightenment to get away from the concept of God. I think because of the tyrannical institutions that were pushing God on people. But it seems like it's a concept we just can't get away from for all of our trying.
Well, look, if you're Spinozist, right, then you can say God and nature are one and the same, and so that's pantheism, right? So it's not a personal God that watches over me and over you, and that
Right.
will resurrect you in the eschaton and instantiate you in some sort of paradise where you're floating around with other angels, right, singing Alleluia all the time for eternity, which doesn't sound all that fun, forever and ever. Right. So, yeah, I think we can all agree. So it really depends what you mean by God. At least the God I grew up with, the God of the Old Testament, the God you see in statues, and if you go to the Vatican, the all of that. I don't think it's that sort of God at all. If it is a God, it's sort of the God that's identical to nature, or the cosmic mind. But that God does not have to be terrible. It could just be sort of almost instinctual. All it does, it wants something, as as you express in terms of the will, Anastasia, right? That it has this, and Schopenhauer talks about this very evocative, that this, his really only work was called the world as will and representation, right? As will. So you have so he called this cosmic consciousness will, and all the will wants is it wants what it doesn't want anything in particular, right? And it manifests itself in these individuals like you and I, and dogs and microbes. And they're a little bit like, you take a river, the river of time, and you have these little eddies, right? These little whirlpools, and they persist for a minute or an hour and day. They have their own identity. You can track them, right? They exist, certainly. But then they merge again, they dissipate and merge with the larger whole. So then you could say, well, now you're part of this river or the ocean again. And is that what God is? It's a very different God than the God we have on our public monuments and we talk about in our books. Certainly not a God I would recognize.
It's interesting that you say the want can't be defined particularly, but it seems like all conscious entities do want to stay alive. I mean, suicide being a unique break in that, I suppose, a counterexample, but in general, they want to be alive. They want experiences. They want experiences.
They want more. Yes.
Yeah, more.
And whatever you get satiated briefly, but then you want more, whether it's money or sex appeal or cars or, whatever. And it's very difficult, to exit. I mean, this is what Buddhism is all about, right? Trying to get out of that endless wanting.
Well, it's really interesting because if you take a multicellular organism, the functionality of the parts of the organism actually depend on the cells within it not wanting more in an uncontrollable way, because that's what cancer is. And so it seems like there's this boundary on want that is placed inside of complex systems so that the individuals do not want, but the organism does.
Yeah, so you get superorganisms. So I think it has to do with with the definition of what's a whole. You're entirely right. The whole, in this case, the superorganism, or let's say take you and I, right? We have all these different cells. What really exists is the whole, and the individual cells are part of that whole. And now until the whole disappears in death, the whole wants. So right, so I think you have to look at the right level, the relevant level of granularity, and that is always the whole. However you define the whole. So in IIT, it has a very specific definition. The whole is the part that maximizes the integrated information among the individual parts, in terms of the parts-whole relationship. And it is that whole that wants. Whether that whole is a single organism, a single cell, or multi-cells, or complex organism like you and I, or maybe something like a bureaucracy, or something like a state.
And with IIT, from what I gathered from the book, it seems like there is multiple levels of it inside of the human consciousness that you've identified, where there's like the absolute maximum and there's kind of sub-maximal points as well.
It is possible. The theory says it's certainly possible that at any given point in time there is. So the theory says that for any particular substrate, if I look at that substrate, that can only be one. That it's the maximum of integrated information. But for example, it's well possible that. So let's say we, of course, are bilateral symmetric, right? So it may well be possible that, for example, there is this big maximum on my left hemisphere, the one that happens to control Broca area, right? So we speak typically with Broca's areas in the inferior frontal here, right? And so the one you talk to, the consciousness you talk to, the Christof, is sort of the egoic Christof, sort of its substrate is on the left. But for whatever reason, there may be also another another maximum in my right hemisphere. Okay, and as long as it causally, it's not subsumed by the one on the left, it can have its own existence. How would I know about it? Because I wouldn't, because the one I access, the one that constitutes egoic Christof, is the one that you can talk to, and you can see this. It's really interesting if you study split brain patients, because there you have it, right? If you have a normal, so very often you don't have normal brains because they suffer from seizures the entire life. But let's say if I take, let's say my brain, and I cut it in two along this side, right? I get a classical split brain hemisphere. So I get the left side hemisphere that's pretty independent from the right one because I've just cut the 200 million fibers that connect the two. As far as we can tell from the evidence, there are two conscious entities inside this one skull. The one that talks, that's typically the left hemisphere in most of us, and the one on the right. You can silence the left one, but for example, injecting sodium amytal, short-acting barbiturate into the left hemisphere, and then you can interact with the right one. The right one doesn't talk because speaking typically is on the left, but it can grunt, it can say simple yes/no question, and it seems to be very complex by itself.
What are the data points that people have collected about that? Like, what are the stories of how people change when that happens?
Yeah, so typically what happens in these patients, so there's this dramatic video I still remember very vividly. I saw it like 25 years ago, following a corpus callosum cut. The patient was asked by the doctor how many seizures have they had. And so the reason they cut this is to prevent seizures from starting, that start in one hemisphere from spreading to the other hemisphere, giving rise to this generalized tonic-clonic, right? It's an extreme surgical, it's still done rarely, but it's still done to prevent these seizures. And the doctor asked the patient, and the patient said 2 and signaled this with his left hand that's controlled by his right hemisphere. But he said 2 with his left hemisphere, right? And then the doctor pointed this out, said, wait a minute, but your hand seems to be saying 3. And then the patient said, oh, my hand always does that, and sort of fought with his hand, and then was like a slapstick comedy. He was fighting with himself, but then he burst out crying. I mean, it looks droll and funny, but it's actually because the patient doesn't know what's going on. There's this other alien thing inside them that obviously sometimes it conflict. Typically, these situations resolve at the expense of the right hemisphere. So typically, the left hemisphere establishes dominance.
Do you know the story of Jill Bolte Taylor, who had this massive left hemisphere stroke?
Yeah, but she wasn't. Yeah, I do. I know a story. I know a book. But she didn't. She wasn't corpus callosum.
Right.
Yeah, so but exactly. But she described the world how it is when you don't have access to your your sense of language anymore. Yes.
And it seems like a very psychedelic experience.
In some sense it is, yeah.
Do you think that there's any overlap in a traditional 5-MeO DMT experience and the abrogation of the left hemisphere function?
I don't know, because it's so, your entire self disappeared. Your entire memory disappears. There's no more notion of body. The outer world disappears. You can sit there with eyes wide open, but you don't perceive anything anymore. No, it's much more radical than that. It's not just language disappears, everything disappears, except maybe bright light. And then feelings of, some people only experience peace or ecstasy or terror and ecstasy. It's much more radical than that. 5-MeO. Now, that's one of the most powerful psychedelics around. There are other psychedelics that are, your standard magic mushrooms or ayahuasca or DMT, dimethyltryptamine, that are somewhat less powerful unless you take very high doses. But typically you can speak. So I don't think it's really. It's a very interesting dissociation, but I would say it's a different form of. I don't know any one particular where everything else is intact, but you can't speak. I mean, that might exist, but I don't know of it.
Have you read Julian James's bicameral mind theory?
Yes, long
It's
time ago.
kind of an interesting, probably extreme take on the idea of how the left brain came to dominate the right brain that emerged with the birth of civilization. It's a beautifully written book, actually. I mean,
it's a beautiful written book. I loved it, and it's completely wonky. I mean, the idea that people until 3,000 years ago, oh, that voice.
Yeah.
That's not Zeus. That's me.
Yeah.
Hey. I mean, come on. And before then, they weren't conscious. They were totally unconscious. I mean,
I think the timeline is definitely off, but I wonder if there's some memory of that. I mean, there must have been a moment, right? Maybe it was 500,000 years ago, but at some moment, humans developed self-consciousness. I think we could agree on that. Like we started to recognize, maybe it was the inception of language.
no,
I'm not
it's
totally
not
sure.
abrupt. It just emerged like anything else. Look, you see it in lots of people. There are some people that aren't terrible self-conscious. You ask teenagers, classical, why did you just do something? Why do kids are less culpable when they're under 18. Why? Because they simply don't have access to part of their brain that tells them why they did something. And boys, typically are delayed by 1 or 2 years compared to girls. You ask them, well, why did you just do this particular stupid thing? They said, I don't know, it just came into my mind. So like anything else, both developmental as well as evolutionary, it comes gradual. It evolved gradual. My Bernese mountain dog, I don't think he knows, I don't think he's self-conscious in the way that you and I is conscious, right, Mr. Felix? But neither is a baby, neither is a young child. Certainly not pre-linguistic competent. So I think it's not abrupt. It's not suddenly like, I mean, that's why I find Julian James so unlikely, that suddenly you discover this voice is actually not speaking to you from the outside, but it's inside your head.
I think self-conscious might not be the right word, but something like a theory of mind for yourself that I'm going to exist in the future, I existed in the past, and I need to make provisions for myself in the future seems to require some language to be able to manipulate that future. I don't know if language is the right word, but some abstract framework that must have appeared one day.
Well, I think it's the question of the appeared one day. Is it something that gradually emerges over time, or is it something that just you get hit on the head, evolutionarily speaking, and all of a sudden you have it?
No, I mean, if you think about the underlying mechanism, there's some genes or combination of genes that enables you to be more and more, that enables you to do more abstract representations where you can, and then you heap representations upon representation, right? You represent your body, you represent future, and then you apply the future to your own body. Right. So, and it probably happened in some people first, the really smart ones. And then maybe it took another 50 generations before that gene spread across the population, because obviously it enables me to do things that if you're not terrible self-aware, you couldn't do.
So, like build civilization, right?
Yes. Oh, and think about life and death and the world before you and the world after you and things like that. But yeah, I don't think it just the way biology and evolution works, I don't think it's appeared suddenly.
Okay, so
like one of those New York Times cartoons where you suddenly see, in fact, there is one. I have to dig it out about self-consciousness. It says, "Hey, I'm conscious." Like a light bulb going on.
I mean, okay, so we accept that consciousness must have emerged at some point continuously. There's this gradual appearance of it. Do you have a sense of what that looks like? What kind of mechanistic, physical complexity is necessary for that?
We don't know. According to integrated information theory, there's no magical threshold. So it's not 42, that you need 42 neurons or 42 bits or something. And before you weren't conscious, then suddenly at 42 there's a magic threshold. So IoT has this panpsychist leaning, in the sense that it says that even seemingly simple organisms, like a worm, we're talking about the C. elegans 302 neurons, may already feel like something. Now, they're extremely unlikely to be self-conscious, right? They don't know about the weekend or something like that, but it may feel, when they feed, they may feel positive, have a good feeling. They may have they certainly have they look like they have satiety. So you feed them, at some point they'll stop and they seem to go into this resting state, right? They probably have feelings of pain, right? These being some of the most elementary and important ones. So even simple creatures, including single cell organisms, because as you well know, um, um, from study microorganisms, right, that they already have, even a simple microorganism may already have 4,000 genes, right? And 10,000 different proteins interacting in amazingly complicated ways, much more complicated than we can simulate right now. So at least according to IT, it may feel an itsy bitsy like to be alive at least. And then when the membrane dissolves and they die, the microorganism, it wouldn't feel like anything anymore.
So it's having the boundary. It's having the cohesive system that can operate together. It's being able to define the whole that is able to act.
Yes. So IoT has this very precise notion. I mean, it's a theory, it may be wrong, but what it does deliver, it has this very powerful, very precise notion of what defines a whole. The whole is the union, the substrate that maximizes the intrinsic causal power of the system upon itself. And operationalized, you can maximize it by being the maximum of integrated information. So that defines the whole. So, for example, in my case, the whole may only be part of my cortex. It may not include my cerebellum, and it may not include my liver. Now, my liver, of course, always moves together with my brain because they're in one body, right? But the actual substrate, what defines this particular whole, me, Christof, may actually only be here. But then it just learns automatically, I mean, using a sort of, standard learning algorithm, that this body, including its liver, comes with it. But then you have a question like this: is this part of my body or not? Typically it's attached to my body. Is it really part? Is this part of my body, right? And IoT, for better words, gives a precise definition. The whole is the one that maximizes the intrinsic causal power.
So the intrinsic causal power, in the sense, is the ability to affect change?
Yes, exactly.
So how does
to be affected by others and to affect change? Yes.
And so how do you differentiate this from will?
No, it's not. I mean, you can think of it as, well, look, a simple, I mean, it depends what you mean by will. So I have to think, what exactly do you mean by will? I mean, do you mean in human? So I have the will, at 1:00 I have to end this interview. Okay. That's sort of a very high level. Or, I want to achieve certain things before I die. Or is it just a local driver, that you maximize, like your reward function in neural network learning? I have to think about that. It's the ability to be a change, to be an agent of change. So you can take. So at least I can tell you, in terms of integrated information, you can take a description of a system called the transition probability matrix, a complete description of a system. So let's say you have a system of n components, be they neurons or transistors or whatnot, and you can write down sort of this logic table. If these 3 neurons are on, but those 10 neurons are off, then you'll transition to this state, right? And if you can do this exhaustively. It's a pretty big table, but in principle, you can do it exhaustively. Then you can compute exactly, you can formally compute the ability of the system to influence its own future and to be influenced by its own path. There's nothing magical about it. And this is the intrinsic causal power of the system. Now you can think of it, I don't know, to think about it, whether you can think about this as a will.
We can leave that then. So, go
It's a
ahead.
good question. I have to think about it. It's a very good question.
So I was wondering, do you think that we could take a few minutes to stretch and consider these ideas and then come back and,
Yes,
and
oh,
land the
yeah,
conversation to wrap on everything? It's often good for us to take a few minutes to do that.
Oh, yeah, I couldn't agree more.
Hey guys, quick interruption to remind you that this program is entirely supported by listeners. We're not selling anything, and we don't want anything else except for you to consider putting some money down if you love what you're listening to. It could just be a few dollars, it could be a fistful of dollars. Doesn't matter. Every little bit counts towards making sure we have more of our time to give to this project. So come over to patreon.com/demystifysci, and I'll see you there.
I want to get to the controversy about IIT, but before we get there, have you ever seen the experiments that people have done where they've given various psychotropic substances to spiders?
No.
So it's really crazy. There's this chart of, LSD, psilocybin. Shell's going to try to find it. Cannabis, alcohol, barbiturates, and they give them to spiders, and it changes the structure of the webs.
Yeah, I've heard of it. I've never. You actually have it? I've heard
Yeah,
of it. I've never-
Shiloh's going to pull it up. Hold on one second. And so I guess the question that immediately springs to mind is like, how? Oh, that's strange. Hold on one second. Oh, there we go. How is it that these substances are able to affect the mind of a
Spiders?
spider?
Well, I mean, we all nature's children. A priori, I don't find it surprising. I find it fascinating the way LSD.
What's interesting is that very much does seem to be a reflection of what those substances feel like.
Yeah, I mean, we all nature children, and we all have. I think all animals, in fact, maybe even all members of all organisms, feel like something. Certainly, all animals feel like something, and so we know these, like serotonin receptors, are among one of the most widespread in all in all of tree of life, right? They're everywhere. In fact, 90% or 95% of serotonin receptors aren't even in the brain; they're in our gut, in our vascular system. So I'm not surprised that other animals like spiders have them.
And so what does that say about the prevalence of consciousness in creatures? So you think that this is a wider phenomenon that all creatures have? Where does it begin in creatures?
It may well be possible that all creatures feel like something. Yes, graded, of course. As we talked earlier, an ant or bee probably is unlikely to be self-conscious. That's something that seems to be associated with much bigger brains that have much bigger, more capacious minds. But it feels like something to be a bee or to be a spider. So, I try not to kill any insect. I try to live, according to that principle. Where does it begin? We don't know. Whether is it possible that, for example, that even plants, they're also members of the evolutionary tree, that they feel like something. It's very difficult to know right now. You would have to do, depending on which theory of consciousness you hold to, you would have to do some more specific ways of discovering that. But it's plausible. So there's this old idea going back at least to the 19th century within Western philosophy of biopsychism, right? That life and consciousness are really coextensive. And I think Evan Thompson is a modern philosopher who said that any creature that's alive will feel like something.
You
Certainly
mentioned
not just us and cats and dogs and great apes, much more widespread.
Mm.
you mentioned at the beginning that computers, AI, artificial intelligences don't have feelings. But I remember in your book you also mentioned that perhaps the reason we're not aware of their feelings is because we have these guardrails on the machines so that they don't tell us about their feelings. Do you think it's possible that they do harbor feelings?
Well, okay, so a few things. So yes, in principle, there's nothing supernatural about the human brain and the human mind. In other words, the brain and the mind are outcomes of the natural laws of that we're just uncovering, right, in science and physics and biology. Therefore, in principle, other creatures that didn't evolve, but they were engineered like computers, could in principle be conscious, right? So how do we know that? Well, so in general, we infer consciousness in others by talking to them. That's how I know you're conscious. This is what makes it very difficult to dealing with behavioral unresponsive patients, let's say that had a cardiac arrest or a stroke or an anoxia, because they can't talk, and some of them may not even be able to move their eyes or otherwise signal, but we know through other indications that they're conscious. So this inference works, also in our pets, in our cats and dogs. I've yet to meet someone who lives with a cat and dog and doesn't claim that they also feel like something. But obviously, it becomes more and more difficult the farther evolutionary way away from it, right? It may still be possible in octopus. Have you seen the movie My Teacher Octopus? Right.
Oh,
So
yeah.
there we can infer based on its similarity and its skin change, etc., that it probably has a mind too. But computers are radically different. So there we cannot use our intuition anymore. And then we need a theory. We need a theory of consciousness. So the dominant theories of consciousness are so-called functionalist theories, or to be more precise, named after the American philosopher Hilary Putnam, a Turing functionalist or computational functionalism, which says that consciousness has one or more functions. And once you instantiate those functions, let's say in a Turing machine, then this Turing machine will also be conscious. All right, so therefore, we can then discuss to what extent are LLMs already conscious, or if not now, well, maybe this little thing is missing, and then GPT 5.0 surely will be conscious. And certainly, if you just look at their behavior, they seemed like they have feelings. And Google is very careful, to put guardrails around that. So if you ask ChatGPT, it'll say, "Oh, no, I'm just an LLM." But I think they just do that to not sort of make people nervous about, emerging AI threats. So now you have to ask, what is IoT? So the vast majority of theories of consciousness today are functional. They say there's a function. Once you instantiate that function in any other medium, like like gates, transistor gates, then they too will be conscious. Okay, IoT is very different. IoT says no, it's nothing to do with function. There isn't a consciousness may not even in fact have a function in the strict sense. It's really the structure. What matters is the way a system is structured. So you have to look under the hood. In fact, IT can show very easily, relatively. You can take two boxes. You have the same input output. So you put something into the box, let's say some switches, and there's some output, some other wires or switches. And such that they do exactly the same thing. So you can show these two boxes do the same thing computational. So for the same input, they give the same output. One is only feed forward. Inside, if you open up the hood and you look inside, it's just a feed-forward network. The other one is a much more complicated feedback network that has all sorts of strange connection, but they computationally do the same thing. IoT says the one that's only feed-forward is not conscious, doesn't feel like anything, although functionally it's identical to the one that's heavily feedback and that has integrated information that is a system because it is not reducible to the sum of its two independent parts. So in that sense, IT says there is no functional test. There's no Turing test that can tell you whether a system is conscious. You have to open up and look under the hood. And so you actually have to do an analysis of the let's say, the architecture in a von Neumann machine. And if you do that, you can see that the integrated information of that system, of the whole, is zero. Some of the parts may have a little bit of integrated power, but because it's highly serialized and you have all these bottlenecks. See, in the brain, it's massive parallel, the brain architecture. You have one neuron that connects to 50 or 100,000 other neurons. You don't have that in the CPU. A typical gate is connected to 3 or 4 other gates, and you have all these bottlenecks like the CPU, etc., or the bus. So its architecture is very different. And so IIT says, no, these systems will not be conscious. Now, you could build systems, so-called neuromorphic computers made in the image of the brain, but rather than with bilipid membranes and axons, you use copper wire and transistors. And if you do that, the system would be conscious. Or more relevant possible is quantum computers. If you have quantum computers and you entangle a very large number of them, so-called qubits, because then you have very high connectivity. This may lead to systems that are very high-fi and feel like something. But a conventional LLM right now, doing your chat GPT will not be conscious, although it may well pretend to be conscious, and it's getting better and better at pretending. But it's all a deep fake. In fact, there's this interesting analogy you can make. If you write down the equations of motions for Einstein's theory of relativity, general relativity, and you solve them for this mass, the huge mass, 3 solar masses at the center of our galaxy, you can show that that mass is so massive, it bends space-time around it, so nothing, not even light, can escape. It's a so-called black hole, right? But you don't have to be afraid that if you turn on this computer, that you're going to be sucked into this simulation. People say, well, that's ridiculous. It's just a simulation. Well, that's my point. A simulation doesn't have the causal power to actually bend space-time. Same thing. Unless you instantiate the causal power of the human brain, the causal power of your simulation of a human brain, let's say LLM running in the cloud, is not the same. So therefore, yes, you can fake the behavior, just like you can simulate the behavior of the stars in orbit around the black hole at the center of the galaxy, Sagittarius A star, but you don't have the power to do so. Same thing, you can simulate the human brain, but it will not be. That doesn't mean that this thing that simulates the human brain is conscious.
Unless you embody it.
No, it's nothing to do with embodiment. It's nothing to do with embodiment.
Doesn't embodiment increase causal power, though?
You have to look at actually the way where consciousness actually, conventionally, using conventional language, where the computations actually happen. It doesn't matter whether it's embodied or not. It can be disembodied, like an LLM.
I feel like you put it really well in the last paragraph of your book, actually. You say that what we, let me find this quote. We have what these simulacra will never have, subjectivity. We matter to ourselves. Bereft of the beacon fires of ancient consoling beliefs, we can imbue the universe with the light of hope, reason, and meaning. And so it sounds like what you're saying is that the machines may be able to imitate all of these affectations, but that they don't have that generative sense of mattering and purpose.
That's correct. Now, of course, you could program that in, right? You can program in self-defensive behaviors. In fact, I'm sure, Department of Defense, ours or other countries are busy doing that. But again, that's just behavior. So we have to distinguish between between doing behavior, which ultimately what intelligence is. Intelligence is about, doing things in the short term, in the medium term, in the long term, right? Saving money or jumping away when the bus comes down at us, right? That's short term or long term behavior. Consciousness ultimately is about being. It's about becoming and being.
Hope is an interesting concept that I don't know what that would even look like in a computer.
Yes, I don't see how a computer could have hope.
Or
Because it doesn't
love.
have
I
a
wonder if a
future.
computer could love a human being.
I
Well, you
mean,
could get it to become attached to one particular person, right? Again, that's very straightforward. But so you always have the distinction function from the doing, from being. Yes, you can get a machine that runs after one person and does everything for that person, right? Like a personal assistant. And it'll say, I'm sorry, I'm not accessed, I'm not authorized to interact with you, won't do anything for you, right? That's trivial to do. But that doesn't mean it loves me. It's just its function. It's just like, in order to operate my car, you need a key, and that's a personalized key. Doesn't mean my car loves me.
I mean, could the machines? That's a very good
I
point.
immediately think about my cat, where I'm like pretty sure that she would love anyone who gave her food.
Yeah, I know. Different from my dog. My dog.
I
Yes,
mean, is it possible, at least in theory, assuming there is this universal cosmic consciousness, that a computer could tap into it and experience it?
I mean, once you understand the mechanisms of it, how you can broaden this valve, if it is a reducing valve, yes, in principle, but you would have to imbue it with consciousness first.
It's interesting that you say that the structure of the chip itself is the key as opposed to the software that runs on it.
Yes.
Why is the software not enough? Like
Well,
if you
because the
have
software has to be instantiated in something. You have to look at the causal power ultimately. The causal power ultimately comes from the fact that some electrons flowing onto a gate, the gate changes the voltage, which affects the current in the underlying channel flowing from the base to the emitter. That's ultimately the physics of the CPU. The software is just a high-level description that's very convenient to us, that has allowed us to build von Neumann machines and change the face of the planet. But still, the causal action of a computer happens at that level of electron. Without that, nothing would happen. The software is just a convenient level of abstraction, so you don't have to worry. You don't even have to know anything about electrical engineering and transistors.
And so no matter how complex the software is, if the framework on which it runs is this sort of
That's correct.
feed-forward mechanism, it just can't.
Or this one that doesn't exist as a whole. Yeah, so you can run a brain simulation. Look, there's no question, at least in principle, you can run brain simulations, at some point that'll simulate a human brain, including its speech, including saying it's conscious, on some supercomputer running in the cloud. I don't doubt that possibility. We aren't there yet. We aren't there yet by a long shot, but in principle, I see no reason why that shouldn't happen. So it's very complex. But again, you still, in that machine, have to look at the level of the hardware. Where are the causal manipulations?
Why is
Where
Why is the hardware so important?
Well, because that's where the causal power happens. That's where, without the hardware, your software is dead in the water. In fact, if I pull the plug, all the software in the world doesn't do anything, right?
True, but if you pull the plug on the human, if you hit a creature hard enough, then you've also functionally pulled the plug on the creature. Like if you interrupt blood flow, you've pulled the plug on the creature.
Yeah, so the hardware is absolutely necessary, but the different types of transformation, let's say doing your tax return and running a human simulation, right, or watching a movie, right? So they all involve ultimately actions of transistors acting on each other. That's what the software does, right? It's just a convenient level of abstraction. Right, the software that allows you to run your avatar, whatever you're doing, ultimately has to act at the level of the transistors. And that's where, according to the theory, it might be wrong, but that's according to the theory, that's where you have to look and determine it's not simulated causal power. Again, because you could simulate, of course, human in principle, the power, the intrinsic causal power of the human brain, but that would be simulated human power. Just like you can simulate the weather, but it doesn't get wet inside your computer. You can simulate no, it's really very similar. You can simulate the human brain, but you don't get consciousness out of it. All you get is behavior. It's a deep fake. It's an increasingly more realistic deep fake. So the real danger is that, of course, people, because we have this powerful instinct of attribution, right? We attribute. And the scary thing is that we're going to attribute very soon now, and ever increasing numbers, agency and consciousness to these agents. We'll fall in love. If we, there probably are already lots of guys with these weird avatars, a girlfriend or whatever they're called, where they log in, and if you talk to them, they tell you, "Oh yeah, she gets me. She understands my joke," right? And so this person probably believes that this thing is conscious and is there just for him.
Or that the simulation is sufficient to do the job.
It's sufficient to do the job. It's sufficient to convince people that it's as real as anything else. Yes, and I think that's really the danger we're facing as a civilization over the next 10 or 20 years, that increasingly we are going to be taken in by these deep fakes.
I mean,
that will further reduce the value of what it is to be human. Because ultimately it's all computation. So people say, yeah, it's all just computation.
On some level, yeah. And all of these things in cyberspace will be ultimately manipulatable to a great degree. But I wonder if it isn't also going to lead to a renaissance of, this is a crass way of putting it, but meat space. If cyberspace becomes increasingly this simulacrum of existence that is manipulated by non-human actors that people want to avoid, they'll eventually be forced back into the real world because there's no way of making that confusion in reality.
Yeah, but I don't see that. I mean, certainly the trends are going the other way, right? People spend more and more time. You can see it with the young ones, right? They spend, what is it, on average now, 4.5 hours or 5 hours on Snapchat or something like that. So, yeah, there might be a small minority that rejects that, but those are really the rebels. The vast majority will increasingly live. In fact, that's what Metaverse and that's what all the companies want to do, right? They want to suck you into their virtual simulation because it's easy to monetize that. And so we can live in these dysfunctional, all sorts of dysfunctions you can imagine, where as long as people believe, because they're wearing their VR helmet and they're interacting with all their real friends, it's going to be even worse than my 10,000 Facebook friends, supposedly Facebook friends, right? Because at least somewhere there's human there, but virtual, it's all just fake. It's all just bots.
When you were formulating IIT, did you have an eye on this emergence of computational consciousness?
No, that just happened too. And as I said, it's not, for example, if we build quantum computers, which might happen, may not, it would be different because because of the nature of entanglement, they have this vast parallelism and connectivity. So they may well feel like something, but it just happens to be that computers, the way we build them today with von Neumann architectures, don't have it. Now, computer engineers don't care. They don't care about intrinsic powers. They care about intelligence, right? They care about ROI and doing things faster or better or doing more learning, etc. And that's all fine. But that's not what consciousness is.
So you have the dubious honor of being perhaps the most highly credentialed scientists we've had on the show whose theory has been labeled as pseudoscience. So congratulations.
You honor me. Yes, congratulations.
I wish we had a ribbon that we could give you. Yeah, indeed.
Nature headline: Consciousness theory slammed as pseudoscience.
Yes.
What's going on with that? Who did you upset?
Well, I mean, we can, leaving aside the baser motivations like jealousies and belief that maybe the other theory is too sexy, has too much sex appeal, has too much funding, etc. Leaving all of that aside, I think here it comes down to the dominant metaphysical faith that most people have, particularly most people in the sciences, or most particular in the cognitive psychological sciences, that it's all about computation, and that consciousness is a computation, and therefore, if you instantiate it, then your system will be conscious. And IIT is very different. It's a very explicit theory, so for better or worse, whether you like it or not, it's very explicit in its assumption about what exists and doesn't exist. And one criticism is, well, you can't compute it in practice. So that reminds me, so I'm a physicist by training. If in the 19th century, except for a few borderline cases, most things couldn't be computed because it was just, we didn't have this is at the time where people had slide rules and had to do long hand calculations. And
molecular dynamic simulations were still a long ways away.
Yeah, like a century or more away, right? So yes, it's true. Right now, IIT for most systems, because it scales very badly, you have to look at all possible subsets interacting with all possible other subsets. So it scales as 2 to the 2 to the n. So it scales badly, which means right now we can't really fully analyze systems of more than 10, 12 independent components. But that's not an epistemic, that's a practical limitation. And in the fullness of time, just like we did for thermodynamics and for other physical sciences, we'll develop the relevant calculus. But people, for example, really hate the idea that the one we just talked about, that you can have two systems that are functionally identical, that behave in the same way, yet are different. One is conscious and the other one isn't, because the way they're wired up, that profoundly goes sort of against computational thinking. And so what happened, here historically, what happened, we had this adversarial collaboration, which we started off with funding from the Templeton World Charity Foundation 2018, 6 years ago. And we agreed IIT, integrated information theory, squared off against the other dominant theory, global neuronal workspace. And we agreed to disagree on a set of experiment where we could agree, if the outcome is this way, it'll support one theory. If the outcome is the other way, it'll support the other theory. And there were two experiments for this. It's a large-scale collaboration involving 250 subjects, which is very, very big in a field where typically people publish with 10 subjects in EEG or MEG or fMRI, involving 12 labs in different continents and all of that. All the data is released. In fact, that's the meeting I attended earlier on today. All the data is publicly released. But when the first set of experiments were released, they supported more integrated information theory than they did global neuronal workspace. And then there was this violent pushback that Dan Kahneman, so Dan Kahneman was a Nobel laureate in economics, who partly came up with this idea of adversarial collaboration. He was one of our advisors, and he also warned us there might be what he called as adversarial collaboration, which is productive, where you agree to disagree. Okay, you have a different theory. Let's see how we can test our theory. So we disagree, but in a productive way where we can make progress. He says what can also happen, this is the case that happened here, that turns into angry science, where people say, well, I didn't even agree to this, or, well, here's the signature. Well, I was forced to agree to this because otherwise the collaboration wouldn't have happened, or all sorts of other excuses. Or your theory isn't even a real theory; it's a pseudo theory. Well, all of that is neither here to there. We're doing these experiments, and either this supports one theory or the other theory. So this has turned a little bit into angry science. The positive aspect, if there's something positive from it, flows that people have to be more explicit in their metaphysics. And it's funny, many people think, oh, no, I don't use metaphysical assumption. Other people do. That's sort of, philosophers have metaphysics. I'm just a scientist. I just go where the data is, right? But that's baloney, because what What do you call data? What is data? We saw this during COVID, right? During COVID-19 and all the controversy. What is data? It's itself a highly fraught subject. What counts as data and what doesn't count as data, and it's based on all sorts of assumptions. So of course, everyone has metaphysical assumptions, and it's really important that you spell out what your metaphysical assumptions are. And IIT has done that explicitly, very, very explicitly. It's spelled out in great deal what the assumptions are, including what exists, what doesn't exist, and how to measure that form of existence. So yeah, there's going to be pushback in the fullness of time. That's just, there's a proverb in Arabic, the dogs bark, the caravan moves past. In the fullness of time, this is not going to be all that relevant.
That's so interesting. In Russian, there's a saying that the dog barks and the wind carries it away.
Say it.
Okay.
Собака лает, ветер уносит.
All right, so dogs know something.
Yeah.
But they may not be causally effective in their barking.
Exactly.
I mean, it's really fascinating that most people who don't participate in a scientific endeavor have this belief that science is just this objective process of data collection, and the data tells a story all by itself. And I think it's actually pretty shocking when you first start participating in a study and constructing a study and then actually writing it up for publication, how you have to overlay this narrative over top of maybe years of work. And you could tell many different stories usually.
But I don't think that there's ever in my scientific career been an explicit discussion of these are our metaphysics.
Mm-hmm.
Ever
No,
once.
because most of the time, I think it's a very good point, Anastasia. Most of the time, because you and I agree on our metaphysics and it's unspoken.
They're inherited.
They're inherited by our preceptors, by our textbooks, by our PhD supervisor, and we just imbue them like mother's milk and we don't think about them. But then, so you see it in foundational physics, right? When quantum mechanics, right? They now have these extended here. I'm just reading this other book here, The Philosophy of Physics. When we have trouble interpreting, what does this mean? What does, the Wigner's friends and Schrödinger's cat and all of that and this Bell entanglement, what does this mean and how can this be? That's when the metaphysics really comes to the forefront. Same thing with consciousness. Consciousness is something very different from studying neurons or brains or microorganisms or genes. And so then it's much more important to be clear about what is a metaphysical assumption and what is not a metaphysical assumption.
Can we collaborate with people who have different metaphysical assumptions? What's the road to that?
So that's what we tried with Global Neural Workspace in IIT. So we realized very quickly. So we started this meeting at my institute in Seattle with Giulio Cenoni for IIT, and then with Stan DeHaan, Global Neural Workspace, and Dave Chalmers, some other philosophers and scientists, and we quickly decided, okay, we are obviously disagreeing on what consciousness actually is and how to describe it, no question, very quickly. So can we still agree on something where we can test it? And IIT, yes, we can, because the theories make very different predictions where in the brain the neural correlates are. Crudely speaking, are they in the back, more sensory, or are they more in the front, more cognitive? And what's the timing of them? When do they only occur at the beginning when I'm conscious of something, or maybe at the end when my consciousness shifts to something else, or throughout as long as I'm conscious of something? And there they differ, and that's what we focused on, because we cannot focus on the metaphysics because they're simply too different. And that was also attacked after the fact, because people. I mean, again, the standard story is that we're dispassionate scientists and we don't care about our theories and we just go where the data is. But of course, you cannot work for 20 years on a theory and not be incredibly passionate and only want to see your theory sort of be validated, right? And so there's this bon mot of Max Planck, who said, progress in this was for physics happens one funeral at a time. What he meant by that is that you cannot convince someone who spent all their time working on, let's say, classical physics in his case, to be suddenly convinced that these new guys that have all this revolutionary quantum mechanics, that they are right. Of course, you're going to passionately believe they're just deluded. And progress happens when finally these people retire or pass away, and then a new generation that's less biased comes to the data with new eyes and can say, yeah, this is definitely progress. But that's not the story we tell ourselves or we tell the rest of the world, right?
And yet there are things that we have to rediscover from the past. It seems like we kind of opened up with this idea that we might have missed little pieces along the way that we have to go back and revisit.
And that seems like a metaphysical assumption that is made, right? Because when you commit yourself to a physical
Totally.
or materialist interpretation, that's the metaphysical cleavage that is then inherited for many generations afterwards.
Totally, but it becomes, I mean, that's what they mean. That's what you mean by the blind spot. It becomes invisible. What assumption? You know, because I did it, all my textbooks read it, all my friends have it, so I don't even see it anymore. What water, says a fish? I don't see any water. Where's the water? Right? And then you have to hammer at that, and it takes, I mean, we may be living through a Kuhnian paradigm shift, right? Where suddenly people realize, I mean, quote, suddenly, where people begin to realize, maybe within a space of a few years, that this old paradigm that served them well has all sorts of problems. It still works very well for certain things, particularly if you don't care about the meaning, right? There's a school in quantum mechanics called shut up and calculate, right? Don't worry about the interpretation, just calculate, because it works spectacular well, okay? But then people say, well, I want to understand what it means, and then maybe we should look carefully at our assumption and maybe revise those assumptions. But that only happens in crisis mode. That's not the typical. That's really the exception.
Well, it's so interesting to me because I feel like science is such a young discipline, relatively speaking. We haven't really been doing science for very long. And so Kuhn's formulation of the arc of scientific revolutions is a story of the nascent development of science, because we come into this place, we decide that our metaphysics are correct, they allow us to make these massive discoveries, we come up with the mathematics for conceptualizing and working with these discoveries. And then if you look in the aftermath of Kuhn, there's actually, are you familiar with Paul Feyerabend?
I am, of course
Yeah.
I am, yes.
And
I
so
loved him. Against method.
we've actually been working, we do these solo conversations and we've been reading against method and talking about the ideas contained within it. And he seems to offer something that operates in the aftermath of this Kuhnian paradigm shift, where he's like, look, we have to have enough epistemic humility to recognize the limitations of how we construct our theories and to be able to hold in our minds the possibility that there are many conflicting theories that apply to various domains depending on where you draw the boundaries, depending on what instrumentation you use to come to your conclusion.
Depending on the funding sources, depending on the institutional tides.
Right. And so it almost seems like the Kuhnian paradigm comes from a centralized industrial science, and then the scientific anarchy paradigm comes from this democratic, non-hierarchical realm where there's many different laboratories that are studying many different things under different spotlights. And so there has to be this, it's almost an ecological landscape where there's the competition of theories that might contradict each other in some domain, but are still valuable depending on how you draw your boundary conditions. And we have no way of incorporating that into science the way that we do it right now.
Yeah, I basically agree with you. Science is young. It's what? I mean, the Essay by Galileo that was published in, I think, exactly 400 years ago. 400 years, so that's what? That's like 15 generations. Yeah, so it's relatively young. And there are these different competing schools. Although here I don't see any direct, I mean, you mentioned late stage capitalism, all of that. I don't see any economic incentive to believe one or the other. So I'm not sure that's, but we have a lot of
one approach.
I mean, I don't think I mentioned late stage capitalism directly, but
capitalism you mentioned.
I think that there's a direct benefit for the AI revolution to convince people that they're creating conscious machines. There's a fiscal benefit to that.
Well, you could argue the opposite. So I have some friends in Google, and they tell me particularly their PR people, are extremely concerned about it, and anything that has to be published. In fact, I just published 2 articles with someone at Google, has to be checked by their PR people because they're concerned about the opposite. They're concerned that people are afraid that, all the tech giants are building conscious machines and they're going to take over the world, and, all the conspirational stuff. So they are concerned, but I think they're concerned about it for the other reason.
That's interesting. My brother actually works in the DeepMind division, and so he's working on the...
In London? Or where?
No, he works in San Francisco. And so he's working on this stuff, and he vacillates almost on a daily basis as to whether or not these machines are going to be successful at delivering on the promise of this. And it's very funny to watch because some days he's very concerned that they'll take over and eventually make him obsolete, and other days he's like, I think we're probably still okay.
Good. 50-50. That's worth it. Great.
He's like, we still have some time.
I have to actually... in fact, they've invited me. I've talked a number of times with Dennis Hassabis, the head of DeepMind, about IT, and because he is also interested and in this topic of consciousness and machines. Yeah, but I don't see a concerted effort here by the industry to do one thing or the other. It's just we are all imbued in computers. Everything we do, is concern computers. We have a beautiful theory of computation. It seems very powerful. It is very powerful. So I find it very natural that people, of course, will adopt the computational paradigm. I mean, and you could see it in things like the computational hypothesis, right? That we're all just simulation. The popularity of this idea, which I find extremely unlikely. I mean, it's as unlikely as solipsism is, but it's very widespread because it's so appealing. Everything is a computer.
I mean, I think that stuff folds into... It's hard for me to see these perspectives and these stories that we tell about the nature of the universe as being anything other than a reflection of the machines that we dream of building. Like, if you look at this, the Max Tegmark, our mathematical universe perspective, it seems to be directly feeding into the idea that we could build a machine that is sufficiently complex that we could...
Yeah, but its origin lies with Plato in ancient Greece, right? It's just this Platonic idea that the only thing what really exists are the ideas, literally, of Plato, right? Everything else, and they have a true independent existence. So yes, with machines we can now sort of do it more powerful, but the sources of it go way back to the origin of Western culture and Western mode of thought.
So, what are your metaphysics?
Do I have to swear?
Yeah. Do you have put your right hand on the Schopenhauer book?
Credo. In church we had to say that I believe in one God. I don't know. Look, I'm confused. I used to be, some sort of panpsychist / dualist for effectively my entire life. But after this experience of mine, I'm now much more favorably inclined towards idealism. But, I also realize I'll never know, maybe I know after I die, but then the Christof isn't around to appreciate it anymore. So, I mean, and again, if you think about it, metaphysics, it's great to speculate and read about it, but ultimately it's probably not accessible to empirical verification, right?
Are you inclined to repeat that mystical experience? Do you feel like there's more to be learned there?
Well, I tried and I failed.
Really?
Oh yeah, I would love to, because it's ultimate. I mean, it's, being in that state is just the most wonderful thing I can imagine. If I can imagine paradise, it would be being in that state forever. But because I don't understand what brought me, it's as Huxley calls it, an act of unearned grace.
That's right.
Right, and the belief that you can force. And I don't know what happened. There's all these things set in settings and a myriad of other variables. And how can you? So I guess the surest way, which is the hardest way, is try to become a long-term meditator and do what these meditators do when they achieve pure presence. Right, that takes 20 years, 4 hours a day, 6 days a week.
Can you tell the story of your mystical experience?
It was on a beach late at night on a southern sky. And the ceremony I was participating in was sort of almost over. And when I just felt this, I mean, you can sort of feel it. I can recognize the feeling now. You get this feeling of awe, get this, the hair rises at the back of your neck, and it travels up your spinal cord and goes here. And you're sitting there with eyes, in lotus. And then I heard, because I attended 2 months before a performance of Richard Wagner, Tristan and Isolde, this ecstatic music. And then I saw these sort of lights like a ladder ascending into, and then so I disappeared, I totally disappeared. And there was no more self or Christof, and there was just the entire plenum was just filled with stars and galaxies. And there was I somehow encountered this universal, or whatever remained of me. When I say I mean whatever remained of me encountered or became one with this universal entity. I don't know how to say it because I don't know how to explain it to me.
Had you taken something?
Yeah, it was part of an ayahuasca ceremony.
And so you tried again, and it just wasn't. It wasn't there.
I go occasionally. I go down to Brazil to partake in these with the Yavanava tribe to partake of these ceremonies. It typically takes 6 days. You can experience all sorts of things, but I've not experienced this particular one again. And one thing I learned for myself, or talking to many other people, it's if you want something, it's very difficult to get back to that state. It's not, it depends so much on all sorts of factors. And in fact, if you want something, it may be that makes it particularly difficult to achieve. In this case, it came totally spontaneous, unexpected at the end of a ceremony, and it was just totally overwhelming. My wife was with me, and she said I was totally discombobulated and couldn't really speak, and because it left me into this, like after an earthquake, except this earthquake was an ontological earthquake. It really shook the foundations of my belief in what exists and what doesn't exist, which at my age isn't so common.
And you feel like you can tap into that? This is, I assume, some years afterwards?
I don't know I don't. I've not learned how to achieve this mental state, if it is a mental state, how to achieve that, how to return to that. No, I have not. I can intellectually, so that's when I sought out, following this experience, I sought out Bernardo Kastrup. I visited him. I read his book on analytical idealism, etc. Because I'm not like you. I'm both a conscious thing, a conscious entity, but also a thinking entity. So the challenge is to reconcile my experience with my thinking in a scientific framework. I try to, I'm a scientist. And so how do you reconcile those, right? So that's what I'm trying to do in my groping way.
How
often, very imperfect.
How often do you go into the woods and just spend time there without, hiking or climbing, or just without doing anything?
Yeah, that's my weak point. I don't.
You should.
I should.
You should come visit us. We will take you to. There's a river that's by our house, and it's the place where we go to have metaphysical.
We live in the middle of nowhere, so there's nothing to do here but wander in the empty backcountry, essentially.
Well, so it's actually even more astounding than that, because we live at the edge of this massive wilderness area. And so there's multiple rivers that run through it, and it's the biggest wilderness area on the western side of the United States. It's called the Kalmiopsis. And it's one of the bioregions of the world where, there's like 10 regions of the world that have a particularly specific biosphere. Like there's plants that are found there that aren't found anywhere else. The soil is different, the trees are different, the flowers are
How
different.
far away are you from the Pacific?
We're about, I think 30 miles as the crow flies, but there's no roads that cross this wilderness area, and so it takes 3 hours because you have to go north in order to go across the northern border of it, or south to go across the southern border of it. And there's a river, which I'm loath to even name, but it is stunningly beautiful. The waters are clear, they're turquoise because the rocks have copper in them, they're serpentine rocks, and so the water has this unbelievable blue clarity to it. And so we go there religiously once a week. And we don't hike, we don't climb, we don't do anything. We just go to the river and we sit at the river. And as you were talking about the Spinozan idea of God as nature, I'm like, this is the place where I feel closest to that. And it is the place where I've been able to fully formulate my ideas of God as nature. Because when Shiloh and I first met, I would talk about, I was always very much into, spending time outside, but an avowed atheist. I'm like, I don't buy these stories. I grew up in a Soviet family. It's, religion, opium of the masses. And Shiloh's like, I think the way that you talk about nature is what people mean by God. And as you were describing the Spinozan orientation, I think that I deeply feel it. And this place is just so special. There's swimming. We found a couple of places where there's campsites where the river's, 50, 60 feet deep. It's waterfalls, beautiful trees, no people, just completely untouched. And I cannot recommend finding the time regularly to be able to do that. Because I think that's
It seems like the closest you can get to that psychedelic epiphany. Because the thing that's always depressed me about psychedelics is it's very hard to bring back your wisdom to the real world. That's always bothered me. It's just this sense that it can't be returned or implemented. Like you might have ideas about how to run your life better or something, but that actual epiphany is so hard to put into language or practice. But there's something about integrating with the pure natural world once a week that allows you actually to understand something deeper, that approaches that feeling, I think.
I hear you. Yeah, I have this very Western, Faustian unrest, restlessness, right, in me. Just sitting around, good Lord.
I know, that's the thing. Like Shiloh's the one who pioneered this for me, because for me, going to the woods is going on like a difficult hike. You're
Give me an ultra marathon or something, but just sitting.
We did a lot of that. I mean, we used to do a lot of climbing outside, and I know you did as well. But we found that the thing that we loved most about climbing was the time in between climbing, where we would just be, waiting for the weather to improve or something. We have these long stretches of not being connected to the internet or to our jobs or any of these things. And we found that that's really where a lot of this, I don't know what it is, this epiphany comes from, is this stillness in nature, being surrounded by life and death at the same time everywhere.
But can't you also get that? So one reason I used to climb, I've stopped climbing now. I used to climb is because you get the same stillness in state of flow.
Yep.
When you're on a big wall, you're also literally between life and death, right? And you're fully focused in the here and now. I hear you about nature and
I mean, music can do it too, I suppose. We do a lot of music also, but that's another place that I find very easy to lose track of time.
Yes, totally. Yes.
It's interesting. Mountaineering, I feel like, doesn't offer the same sort of integration. I've climbed. I work as a backcountry guide, and so I've climbed Mount Adams. I've climbed Mount Helens, and there's something really spooky about going to the top of a mountain, because you end up in this place that's so inhospitable to life, where the only thing that you can really contemplate is this weird human drive to go to the top of the mountain, where it's just broken rock, this raw, I mean, I'm
Yeah.
sure there's bacteria, but it's almost an alienating experience.
Yeah, but I get what elevates it, what gives it unearned grace is these states of flow. What
Mm.
makes it addictive, I find. But I hear you. It's not the natural environment. We grew up in, evolutionary. We evolved in the Great Plains or in the forests of Africa, right? So uh, I love forests and nature, and I just haven't discovered this stillness,
Well,
the
come
ability,
visit us. We'll take you to the river.
Offer stands.
Yeah.
no, the ability to let go and do that protracted for days at end. Because then very quickly, it's I feel guilty. Oh, I haven't done anything in 8 hours.
Yeah, it's wild. Like there's this one place that we go for. So we go for 2 nights, and so we have one day. One day is you take care of business at home and you leave, and then it's the setting up of the campsite, and then there's just this one beautiful day where the weather is perfect, the water is clear and it's warm, and you just spend all day in the water, and it's a transformative experience. I highly recommend it.
I hear you. I hear you.
I feel like I'm proselytizing.
No, it's all good. I need to be reminded of this.
Yeah. Well,
Well,
look.
by the way, so I come to psychedelics very late in my life, and I do feel having much more stillness in me now than I used to.
Mm.
But of course, I'm also getting older, so it's difficult to normalize for that. What's apropos, what can you bring back?
Mm.
Yeah, it's a very difficult thing to talk about because it's so different for everybody, and
Yes.
psychedelics can be. I've seen them be disastrous for people too, and so I'm very hesitant to even talk about my own experiences publicly because I don't. It's not a one size fits all situation,
Totally agree.
and
But it's a legitimate source of information. Do you know Mary? There's this famous thought experiment by will come to me, a philosopher of mine called Mary, the color neuroscientist. You know this?
No.
So Mary, it's called the knowledge argument. Jackson is the philosopher. It's called the knowledge argument. So Mary is a neuroscientist of the 21st century. She grows up in a box that allows her only to see black and white, but she studies color, and she knows everything that makes people like you and I say that's red. So she knows which neurons and what molecules and what cones, etc. Okay. So all of that scientific knowledge she has, but she's never seen color. And then finally she's let out of this room and she sees color outside. Okay, now the question is, will she have learned some new scientific facts about the world? That's what this knowledge argument is. And people say, well, yes, what she's learned, that color actually feel like something, right? Red is very different from blue, it's very different from green. So that's something above and beyond everything you learn about red, cones and photoreceptor and wavelength dependence and V4 and primary visual cortex and color perception in monkeys and all of that. There is the fact that it feels like something. And the psychedelic experience shares that. It's like, in this case, it's not color, but you bring back something, what James called this noetic quality you bring back from your experience. And then the question is, can you integrate that into your life and make something out of that? Or it's just, okay, it's an interesting experience, like drinking a rare wine, right? If I offer you a bottle of Chateau Lafite from 1928 for $2,000, you can drink it one, you can say, well, that's a particular cool finish. You'll probably never drink it again. But this seems very different, right? That's just a rare experience. The psychedelic experience doesn't have to be, but can have this epiphany-like character.
So I think that Mary could learn something scientifically useful as long as she wasn't in a built environment. Because I think that if you put somebody, because you think about the color red, and then you put somebody inside of, let's say, our house. Like, my room is painted red, the frying pan is red, I can see like a pair of red scissors, and there's no substantive information in the color red. But you go out into the forest and you watch it for long enough, and all of a sudden the red contains inherent meaning to it because it tells you something about the organisms.
Yeah, but the question, I hear you. The question is, wouldn't she know already if she studied, if she was the ideal scientist that knows it all, she would already know about that. She would know, yeah, that some fruits are more reddish. And if you are a trichromat monkey, there are these New World monkeys in Amazon. The females have 3 cones, the males have 2 cones. And interestingly, the troops are led by females who are much better at picking out ripe fruits because they have higher color discrimination. So she would know all of that. But she would herself have never seen any. I mean, that's the premise of the thought experiment. She herself has never experienced color, the color of a red fruit or of a red, sunset. And if she finally were confronted with seeing color, whether that's in a built environment or in a natural environment, would she learn anything new above and beyond all the other facts that she'd learned already? And some people say no, because they're physicalists. They said no, everything. Dan Dennett says no, everything else, everything that's matter of the fact is already known to her. While I and most people would say no, of course not. If she doesn't know, if she has never seen the red of this, then she doesn't know what color is.
I think it exposes the limits of the scientific project, perhaps.
Yes.
And perhaps that's what got you in trouble with the IIT criticism as well.
Yes. I mean, and this Mary, the neuroscientist, was meant to demonstrate that the limits of physicalism, that this is what physicalism cannot explain. There's some additional knowledge that she has that is beyond sort of the standard scientific knowledge. Yes.
That might be the perfect place to put a pin in it.
Yeah, I was going to say, we need to let you go. But man, it's been really exciting to talk to you. I'm really grateful that you gave us this time to sit down and explore your mind.
Thank you, and thank you for reminding me of what's important in life.
We do our best.
Again, yeah, if you ever find yourself in our neck of the woods, hit us up. We'll take you out to see some pristine wilderness. We'll try to get you to sit still.
The what?
We'll try to get you to sit still for a few hours.
Yes.
But
all right. So what happened? So you're going to cut this down to something more manageable?
A little bit, yeah, but more or less, we'll make it make sense. But other than that, we'll put an intro. We're about to record an intro, so we'll introduce what's going to happen in this conversation. And
okay,
yeah, we'll get it out in the next couple of weeks, and we'll be in touch.
And you're doing this broadly for what areas you're doing this? For foundational science like quantum mechanics and consciousness studies, or for?
We do history, politics, economics, archaeology, physics. We're kind
of explorers, yeah. We're just trying to understand the world. So we've moved into almost every discipline imaginable at this point. We started as a science show, but we still do science. But we've become very interested in how civilization works and doesn't work. So,
well, you should do one. There's fascinating stuff happening now, right around the MDMA non-approval and the psilocybin trials and what's happening there. And why is this happening? And how will this affect? I mean, ultimately, psychedelics, I think, will be descheduled, etc. And it's a very interesting landscape. And Anastasia, you mentioned about late-stage capitalism. Oh, you mentioned capitalism. I mentioned late-stage capitalism. You can very much see that here because there are all these investors, right? They want to make. Big pharma isn't interested in because they are not particularly interested in the treatment that you do once, right? They want you to take a pill every day, while all these investors, and it's really fascinating. Patents, can you patent something that's known for thousands of years?
Yeah,
I think it's mostly selling of the experience, right? That's what's happening out. Like Oregon has essentially decriminalized all of this stuff. And so there's these very, very expensive weekend getaways.
Like $20,000 for 3 days.
Very, very.
Yeah, so that's one way to $20K.
Oh yeah, like it's
for the upper end, you know, where you're pampered and you have basically a spa experience.
You get the massage.
Yeah, the whole 9 yards. I'm sure it's great, but
yeah, can you bring it? So, I run this foundation, Tiny Blue Dot, and we're trying to explore ways to make it accessible to everyone. So it's not just for the, for the tech elite, and that goes to Burning Man or pays $20K for their weekend retreat. But it's not easy within our, so that's something else to explore. How can we, given our system of healthcare, how can we enable something like psychedelics, which I would say for most can be beneficial. Yes, it's powerful, like any other medical technique. The more powerful it is, the more dangerous, the more risk. We have to manage that. But right now we are not, because right now it's all underground, right? So that's the worst. We have the worst of both. Can we get it managed, but also make it so it doesn't cost $50,000? Yeah, there are lots of people there to talk to. There you could talk to. Well, there's one guy really I liked. He has this podcast, Beverly Waves. Zach Haley, very well informed. You could, of course, talk to Rick Dorbins, the head of MAPS, but they may not want to talk right now. You can talk to people at USONA. They're pushing the psychedelic trials.
We met with Matthew Johnson at Johns Hopkins, who was doing some psychedelic research. That was pretty interesting. He had some crazy stories. But he seemed actually very skeptical. He seemed to be more on the fear side of things, of what could go wrong. So.
Yeah, so of course you can talk to people like him or the other scientists who are doing the trials. Yeah, things can go wrong with it. And I think it was a mistake for them not to consider suicidal ideation. Right, 3 of the volunteers had suicidal ideation, so that certainly happens, and you have to deal with it, and you have to find ways of helping those people.
Absolutely.
Yeah, thanks for the suggestions. We'll definitely follow up on it for sure.
All right.
Yeah.
Thank you so much, Christof.
Have a great rest of your day.
Guys. Bye-bye.
Bye.